everyone, I'm Diksha Kaushal, your chemistry master teacher. How are you all? How are you all? Tell me in the chat box. Tell me in the chat box. Everyone active in the chat box. How are you all? Am I visible to everyone? Firstly, tell me if I am visible. Am I visible to everyone? Am I audible to everyone? Please tell me in the chat box. Okay. There's no issues in the video or the audio? Yes, even I was waiting for a very long time to take this class, but due to studio and technical operations, it was stuck. But now I am very happy that finally we are starting off with organic chemistry. So are you all excited? Is the voice audible to everyone? Please type in the chat box. Very good. Okay, no issues. Perfect, perfect, perfect. Okay, so guys, as I told you, chemistry, we are going to focus on organic chemistry, your pain point. Like most of the students that are very scared of organic chemistry, is it? So tell me how many of you are very scared of organic chemistry and how many you have a very good hold over organic chemistry. Okay, tell me in the chat box, bacha, stay active in the chat box so that we can together study with a lot of fun, not a very boring study, but we can study with a lot of fun. Okay? Yes. Excited? Okay, perfect. So how many you have are scared of organic chemistry and how many you are how many of you think that you have a very good hold over organic chemistry? Firstly, I should know my students. Me too much scared, excited, very much. Okay, audio is not clear. Is it? Is it the case? Yeah, I am scared. So guys, don't worry. I am here. I am here to boost up your knowledge of organic chemistry. So guys, as you all know, all the concepts of organic chemistry are totally interrelated to each other. We can just pick one topic, one chapter, and if I say, okay, let's start with alcohol phenols, let's start with the carboxylic acid. No, this is not how we are going to study organic chemistry. I'll focus on every student who is sitting here who have zero knowledge of organic chemistry. I'll make that student also the hero of organic chemistry. And what will be our strategy? Let us firstly discuss about that. So do you all want, just wait a minute, yeah. So do you all want that someday after 2 months, do you all want, type yes or no, do you all want that you want to have a very good hold over these kind of conversions? Can you see that? These kind of conversion charts from benzene to phenol to this is, there are so many reactions here. Nitrobenzene, and this is so many reactions, this is disodium salt. So many reactions are here, right? So, if we want to have a good hold over conversions, what we need to do? Should we directly jump to these conversions or should we apply some different strategy? So, let us see. Okay, these kind of conversions, I want you all to have a very good hold over these kind of conversion. You, one day after 2 months, you will not be scared of what is this, ma'am. You will be like, okay, ma'am, we know this. Okay. So do you want that kind of organic chemistry or you want just cramming? What you want? Ma'am, focus on the camera, is it? But I think the images are little blurred. But if when I'll start teaching, if you still face that thing, I'll focus on the camera, okay? Okay? Done? Okay, very good morning, bacha, very good morning. So, to have a good hold over these kind of conversions, what we are going to do, we are going to focus on basics of organic chemistry firstly. Basics of organic chemistry, what all, ma'am? Firstly, we will focus on hybridization. As we all know, there is a little part of hybridization in chemical bonding. So, if you are not good with chemical bonding also, then we will pick that part from chemical bonding, and today we will learn a little bit about hybridization of carbon, nitrogen and oxygen. After that, we will switch to IUPAC naming and then common names. Very important common names. Now ma'am, why are IUPAC naming and common names so important? So I'll show you one example. First thing is, they will directly ask you IUPAC naming. Yeah, directly ask you IUPAC naming of polyfunctional groups, difficult IUPAC naming, not easy ones, difficult IUPAC namings. But after that, What else? Can you see these questions? These are previous year questions. Okay, these are previous year questions. So as you can see, this one, this is to 2021. They have asked this question in 2021. And the option is full of IUPAC naming. The question is full of IUPAC naming and common names. Right? That means you need to have a good hold over IUPAC naming and common names. As you can see, the second question, what is acrolein? What is allyl alcohol? What is formic acid? What is glycerol sulfate? You need to know what are the structures of these compounds. If you don't know that, you won't be able to do this reaction. So, for that also, we need to have a good hold over IUPAC naming and common names as well. Some of the very important common names. Okay. So, for that, I am going to start this lecture. Okay, but so this is the schedule. This is your schedule. So I'll also give you the PDF. You can see the schedule and accordingly you can fix your timing. Okay. Now, yes. So firstly, discovery of organic compounds. So let me see how many students are here. So guys, today now I am going to start. Audio is not clear, is it? Or you are just making it yourself? Is it? Okay. So let's start. From this point, we are going to start our lecture. Okay? Yes. But if you can adjust for today, I'll make the correction by tomorrow. Okay? If you can adjust the voice today, I'll make the correction tomorrow. Okay? A little bit adjustment from your side. This is my first class. Like yesterday only the studio got set up. So there's little things that I'm not aware of that much because I'm not a technical person. I'm a chemist. I'm your chemistry teacher. I'm not a technical person. So that's why I don't know how to undo that. But I'll make sure that you don't face this issue again. Okay? Yeah. It's like alien voice, is it? Don't worry. You always see organic compounds. For some people, organic chemistry is alien to them. So you can take my alien voice also. Okay? Chalo. So let's start. The students who are asking for hydrocarbons, alcohol phenols and all those chapters. So guys, I'll focus on those chapters. But before that, I want you to know GOC, inductive effect, resonance effect, electromeric effect. What is hyperconjugation? Without GOC, you will not be able to do any organic chemistry reaction. It will all be just cramming. So for that, you need to have a very good hold over GOC. Okay? So just follow what I say and you will rock organic chemistry. That's my promise to you. Okay? So let's start. So first thing is discovery of organic chemistry. First thing is discovery of organic compounds. So can anyone tell what was the first theory? These things you have studied in 9th and 10th also, right? So a little bit of that. So first thing that we have studied was vital force theory. That was vital force theory. So vital force theory, what does it tell? Vital force theory that was given by Berzelius, it told us that organic compounds are derived from living organisms. It can only be derived naturally. It cannot be derived artificially or in any lab, right? So that is vital force theory. The main force of organic compounds is us living organisms, plants, animals. These are the main generating force of organic compounds. That was a theory back then given by Berzelius. But after that, one organic compound was prepared in the lab. Can you please name that one organic compound? Very good, perfect. So that was one organic compound, that is urea was there. So many students have also written the formula of that organic compound. Perfect. So many students have also written the formula of that organic compound. Bahut badhiya. Okay. So bacha, urea. Who derived this organic compound in the lab? Can you name that scientist? What is the name of that scientist? That was Wohler. So Wohler derived this compound from an inorganic compound in the lab. Okay, so Wohler derived this compound in the lab. Is it? Okay, so now, yeah, so I'm writing a reaction here. Can you please tell me what will be the products? What will be the products after this? What will be the products? Here we are generating. This is inorganic compound. What is the name of this compound? What is the name of this compound? This is an inorganic compound. From this we will derive organic compound, that is urea. What is the name of this compound? What is the name of this compound? Yeah. This was given by Wohler. This was given by Wohler. He prepared one organic compound in the lab, right? So after this, just displace these two things. So we get NH4OCN plus KCl, right? This is KCl, NH4OCN, right? From this particular compound, urea was formed. NH4OCN, then NH2CO, NH2. This is urea, right? This is urea. This is an inorganic compound named potassium cyanate. This is potassium cyanate, an inorganic compound from which in the laboratory an organic compound was derived. First time in the history an organic compound is derived artificially in the lab, right? So that was an amazing thing that they did. They thought, okay, if we have derived one organic compound, we can also derive other organic compounds. So what are the other organic compounds that were derived in the laboratory? Can you tell me? Okay, just tell me who derived acetic acid? Who derived acetic acid in the lab? Who derived acetic acid in the lab? Who derived phenol in the lab? Who derived methane in the lab? Can you name these scientists? Okay, first is acetic acid, then phenol, then methane. Who derived in the laboratory? I am saying. After Wohler discovered organic compound urea in the lab, there were other scientists also that started deriving other organic compounds. So these are few main organic compounds that were derived after urea. So can you name this? Kolb's. Very good, very good, very good. Very good, very good. Kolb. Very good. And what about phenol? What about phenol? Kolb, acetic acid, perfect, perfect, perfect. Who derived phenol? Who derived phenol? Who derived phenol? Yes. Who derived phenol? Carl. Right? And who derived methane? This is very easy. Very easy. Yes, who derived methane? That was Volta. So this can be asked, this cannot be asked, not a very, very important thing, but you must know this. Okay, you must know this. By chance, if they ask you, these are the only things that they can ask. After this, nothing can be asked from this discovery, right? So now, we are going to start with hybridization. So guys, if we all know, organic compounds is basically carbon containing compounds along with other elements like hydrogen, oxygen, nitrogen. So we should, before jumping into organic chemistry, we should know the hybridization of oxygen, nitrogen, carbon, right? So very easy thing. We are going to firstly learn this. We are going to firstly understand this. After that, we will do a trick and things will be very easy for you. So see, bonds formed by carbon in alkane. So very easy, just understand this along with me. Okay, so let us take an example of alkane, that is methane. Okay, let us take an example, that is methane. If you have a very good hold over chemical bonding, then you will find this very, very easy. Okay, if you find chemical bonding little tough, then this will make you understand that, and so that your organic chemistry further is very smooth. Okay, so now this is methane. This is methane. We know in methane, we have carbon is bonded to 4 other atoms. Carbon is bonded to 4 other atoms, right? So see, we have, what is the electronic configuration of carbon? What is the atomic number of carbon? Hydrogen, helium, lithium, beryllium, boron, carbon, right? Okay. Okay, so hydrogen, helium, lithium, beryllium, boron, carbon. So this is 6. What is the electronic configuration? That is 1s2, 2s2, 2p2. This is the electronic configuration. From the outermost shell, that is 2s2 and 2p2. We are going to focus on the outermost shell, not the inner shell. So the outermost shell here is 2s2 and 2p2. Okay, so let's draw a diagram here. This is 2s and this is 2p, right? This is 2p. In 2p, we have 3 orbitals. That is px, py, pz, right? That is px, py, pz. So in 2s, you have 2 electrons. And in 2p, you have 1 electron here, 1 electron here. 1 electron here, 1 electron here. So now, as we all know that, this means, firstly, let me tell you one more thing about bonding. About bonding, always remember, bonding is done. Only bonds are formed under 2 conditions. So first condition here is, there should be opposite spin. An orbital should be half filled. What do you mean by that? Ma'am, this is not half filled. Ma'am, this is not half filled. These are half filled. Okay, 2s is not half filled. 2p is half filled. That means this will not take part in bonding. That means it will form only 2 bonds. But this doesn't exist. It forms 4 bonds. That means something will happen here. Some rearrangement will happen here so that all these 4 orbitals are half filled. What is that called? That is called excited state. That is called excited state. So now what will happen? What will happen in the excited state? The electron will jump to here, right? So there are 4 orbitals now, that is in the excited state, right? 4 orbitals in the excited state that have opposite spin and that are half filled. That have opposite spin and that are half filled. Ma'am, opposite spin meaning? What do you mean by opposite spin? So let us discuss what do I mean by opposite spin. That means the bonding will happen. The covalent bond will be formed only when this orbital coming will be half filled. This will be half filled and these 2 orbitals will have opposite spin. This will have a spin like this and this will have a spin like this. This will have, one will have plus half spin and the other will have minus half spin. Only then bonding will happen. Okay, only then bonding will happen. Okay, the electrons are also very excited. Bilkul right. So the electrons are also very excited, just like you. Okay, so they got excited from here, right? So now what will happen? These all are in the positive spin. Let us assume this is in the positive spin. Now what we need, 4 hydrogen atom of opposite spin, so that they can form a bond with this. But now one more thing will happen, that is hybridization. What is the reason for hybridization? Okay, let us see. So guys, first thing is, here if 1 electron from this and 1 electron from hydrogen, let us take hydrogen as a pink color, right? Pink color, right? Usually they say pink color is the favorite of girls, but what is this stupid assumption, right? Pink color is not my favorite. My favorite color is black. So many girls will get offended here. Ma'am, why? We don't like pink, right? So I don't know why this is that assumption. Pink is favorite color of girls. Blue is favorite color of boys. What is this assumption? I don't understand that. Okay. So guys, this is 2s, right? You will have a s orbital of hydrogen. Hydrogen has only s orbital, right? So if I assume there is no hybridization, then what will happen? This s orbital will get bonded with another s orbital of hydrogen. This p orbital will get bonded with hydrogen atom s orbital. This will get bonded with hydrogen atom s orbital, and this will also get bonded with hydrogen atom s orbital. This means 3 bonds will be same. 3 bonds will be same and 1 bond will be different. But is this the case? Do you think that in methane all the CH atoms, all the CH bonds have same bond lengths, or do you think 3 have same bond length and 1 has different bond length? No, right? No, right? Tell me. My favorite color is green, ma'am. Even I love black. Black is like forever. Black is forever love. That's why I'm wearing this black t-shirt. Right? Black is forever love. Okay. So guys, do you think all the CH bonds will have same bond length? Is this the case? Tell me. I can't see anyone saying yes or no, yes or no, yes or no. Tell me what is this? I can't see your comments. Just give me a minute. Just give me a minute. Okay. No, right? They will not have the same bond length. What is the reason behind that? Because now here hybridization will happen. Now hybridization will take place at this point. So what is hybridization? Hybridization is like you have 4 buckets. One is having red color, other is having blue color, one is having black color, your favorite colors. Okay? You have 4 different colors in 4 different buckets. Now what you'll do, you don't like any color. So what you decided, okay, I'll mix them all. Okay, I'll mix them all. So you mix them all and then put them on in the different buckets. Those 4 different buckets, you mix that and a new color is formed out of it. Right? That is hybridization. So I will mix all these 4 orbitals here. All these 4 orbitals. As the carbon is forming 4 bonds, I'll mix 1s and 3 p orbitals. Okay, bacha? So do you understand this? I'll mix 1s and 3 p orbitals. This is 1s and these are 3 p orbitals. That is called sp3 hybridization. Right? So now the hydrogen atom will get bonded to sp3 hybrid orbital of carbon atom. The hydrogen atom will get, the 1s orbital of hydrogen atom will get bonded to 4 sp3 hybrid orbital. Okay, we have combined 4 orbitals that will form 4 sp3 hybrid orbitals of the same energy. This will have same energy. That is why CH bond length will be same. Right? Understood? Have you understood the concept of hybridization or not? Have you? Okay, bacha. So opposite spin means this will have, for example, a bonding is occurring between 2 orbitals. So this orbital will have spin like this and the other orbital will have spin like this. These are the opposite spins. Okay? These are the opposite spins. So is this clear to everyone? Is this clear to everyone? Is this? Yes. This is sp3 hybridization. Now coming to alkene. Now this will be very easy for you. This will be very easy for you. Okay. So now let's just draw ethane. Okay. Let us draw ethene. Ethene. What is ethene? What is ethene? Carbon double bond and here is CH2 and here is CH2. Now what is this double bond? One is sigma and one is pi. We all know, ma'am. But how is this 1 sigma and 1 pi? Let us understand that. Okay. So now, as you know, this carbon, wait a minute, yeah. This carbon is having hybridization, not hybridization, electronic configuration, this. This is the electronic configuration of carbon. That means considering the outermost orbital, this is 2s and this is 2p. And this is 2p. So I have 3 orbitals in 2p, right? So after the excitation of electrons, because they want half-filled orbitals. That is why excitation is happening here. So after the excitation of orbitals, of the electrons in the orbitals, what will happen here? After the excitation, now you will think, ma'am, what kind of hybridization will be here? Will it be sp3? Will it be sp2? Will it be sp? So the simple method, the very simple method of knowing this is how many bonds it is making. How many bonds it is making? So this is ethane. This is ethene. 1, 2, 3. It is having 1 carbon atom is having 3 other atoms attached to it. It is having 3 other atoms. This is 1H, this is another H, this is 1C. So if 1 carbon atom is having 3 other atoms attached to it, what will happen? It will need 3 hybrid orbitals. So how will it will have 3 hybrid orbitals? 3 hybrid orbitals can only be formed when we have 1s and 2 p orbitals. Now, out of these 3 p orbitals, I got, like, you have 4 buckets. You have used 3 buckets for your mixing. But 1 bucket is remaining. 1 bucket is left. Okay, 1 bucket of pink color is left here. Pink, I don't like pink color. So 1 bucket of pink color is, I'm not using that. Okay, so this one I have not used this one. Okay, let's just take an example. I have not used this one. Okay, these 3 are the hybrid orbitals, that is sp2 hybrid orbitals, plus 1 is left, that is pz orbitals. So now what will it form? These 3 sp2, these are 3 sp2 orbitals will form 3 bonds, will form 3 bonds. 3 bonds with whom? They will form 3 bonds with different atoms. One is carbon, another is hydrogen and hydrogen. This will form sigma bonds. This will form sigma bonds because this is between hybrid orbital and another s orbital. This will form simple sigma bond. But now this p orbital will be like this. Okay, it will be like this. So because these are parallel to each other, this carbon, let me show you. See, this carbon will have 1 p orbital. This will have 1 p orbital. That is unhybridized, having 1 electron in it. So now what will happen? This will have 1 electron. This will have opposite spin, 1 electron. And what will happen? Sideways overlapping will happen here. What is the name? Sideways overlapping. Okay, sideways overlapping. These are parallel to each other. So they will overlap like this. And they will form pi bond. What will they form? They will form pi bond. Right? So that is why we have 1 sigma and 1 pi bond here. Because of sideways overlapping. Is this clear? Network issue, is it? So I can see myself. So I don't think so there is some network issue. If you are facing, yes. Okay. Pi bond is formed. Perfect. So now let us see alkyne. What is alkyne? Arey man, this is also very easy. Now you tell me what will happen here. Very, very easy. So now this is CH, triple bond CH. Ma'am, now this carbon, the hero of our organic chemistry, this will have the same case, that is 3, 1 2s orbital, right? And 3 2p orbital, right? Px, Py and Pz. This is 2s and this is 2p, right? Excited state, and this has 4 electron which are half filled. So now what will happen? Here, ma'am, 1 carbon atom is bonded to 2 other atoms. 1 carbon atom is bonded to 2 other atoms. So 2 other atoms means it will need 2 hybrid orbitals, and for that it just need 2 buckets. We just need to mix 2 buckets, right? We don't need other buckets. We will separate out pink color and blue color. Okay, we will mix white and black color. Okay, just an example. Don't take this by heart. Okay, so what we are going to do now? We'll mix 2 buckets. That means 1s and 1p. 1s and 1p. And what will be left? Py and pz will be left unhybridized. This is unhybridized and this is hybrid orbital. So what we do here, hybrid orbital of carbon will form a sigma bond with hydrogen atom here and hydrogen and a carbon atom here. Okay? This carbon atom is forming a sigma bond with hydrogen atom here, and this carbon atom is also forming a sigma bond with this carbon atom here. Right? That means it will form sp, sigma bond, sp, s orbital, sigma bond. Do you understand this? sp, s orbital. That means s orbital of carbon and s orbital of hydrogen. They will form a sigma bond. They will handshake. Okay? They will shake their hands, right? They will shake their hand. Hello, hi, right? So now what will happen now? What will happen to these 2 unhybrid orbitals? What will happen? So see. Suppose this is pz orbital. This is pz orbital of first carbon and this is pz orbital of second carbon. They will start overlapping and form a pi bond. suppose this is y orbital, right? They will also start sideways overlapping and they will form 2 pi bonds. They will form two pi bonds will be formed here and 1 sigma bond will be formed here. So if in case you are being asked tell me what is the bond between these two, what is the bond, you will say sp, s orbital bond, right? Okay, chal. Now let us start hybridization trick. Now you don't need to do all this in exam, right? This is just to clear the concept. I don't want just to get into you one trick and just cram it. I don't want that, right? So what we will do, we will firstly understand and then we will see a trick on that, right? Very simple trick. You have, just write it 4, 3, 2. Okay, just write 4, 3, 2, and 4 means it will form 4 bonds. So 4 bonds mean sp3. So this is 3, 4. You have 4 now. 3 plus 1, that is 4. Now you need 3 bonds. So you just need sp2. 2 plus 1, 3. 2, that means sp. That's it. If it is forming 4 bonds, then sp3, it is forming 3 sigma bonds, then sp2, it is forming 2 sigma bond, then sp. Right? So what do you mean by groups? What do you mean by groups here? So these are the groups. This is the hybridization. This is hybridization and these are the groups. So what do you mean by groups, ma'am? What is groups? What is groups, ma'am? We don't understand groups. So see, very simple. In group, you will take sigma bond. What we will take? In group, you will take, even if there is double bond, you will take it as one group. It is triple bond, you will take it as one group. It is single bond, it is taken as one group. So that means group only refers to sigma bonds. That's it. Group refers to sigma bond. Got it? Okay? Very simple. So after this, it will be very, very easy for you to know the hybridization of any compound. Any compound. When you go deep in organic chemistry, the kind of concepts that are asked in NEET exam, then you will know the importance of these things, the importance of hybridization, because most of the students lag behind this and they don't know how to solve very complex questions because the base is not clear. If the foundation is not properly done, then how can you build a very strong building? If the foundation is weak, the building will collapse. Immediately the building will collapse. So do you want to have a good foundation or a very weak foundation? What you want? You don't want your building to collapse, right? Nobody wants their building to collapse, right? That is why these things are important for you. Okay, so now next is hybridization of nitrogen with 3 atoms. Now this is also very, very simple. So now do this with me. Okay, do this with me. You know what is the electronic configuration of nitrogen? What is the electronic configuration? Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen. Nitrogen means 7. Nitrogen means 7. What is the electronic configuration? 1s2, 2s2, 2p, 3, 3, 4, 5, 6, 7. This is the electronic configuration. Now talking about the outermost orbitals. There are so many wires here. Okay, so talking about the outermost orbitals, this is 2s and this is 2p. You will have 2 electrons here, 1 electron, 1 electron, 1 electron. Now, just see. I have written here hybridization of nitrogen atom with 3 atoms. You can draw any structure, any organic structure, any structure in chemistry if you know these things, right? So now, nitrogen with 3 atoms. Nitrogen with 3 atoms. An example, like ammonia, right? Like ammonia, right? So nitrogen with 3 atoms, NH3, right? So how can we know nitrogen is having one lone pair? Let us discuss that. 3 atoms means it will form sp. So how will the hybridization goes? Okay, for 3 atoms, for nitrogen atom, the hybridization is sp3 hybrid. Okay, the hybridization I am writing it here. The hybridization is sp3. So how will this happen? Hybridization is sp3. You will have 4 same energy levels having sp3 hybrid orbitals that will have 1, 2, 3, 4, 5 electrons in it. 5 electrons, how will you fill that? 1, 2, 3, 4, 5. Now you have these electrons. Did you understand that? Do you understand that? Nitrogen with 3 atoms has sp3 hybridization. S having 2 electrons, P having 3 electrons. Total they have 5 electrons. 5 electrons, but the hybrid orbitals are 4. So how will we fill the electrons here? The electrons will be filled here like this. This is 2 electrons, 1, 1, 1. This will be filled like this. Now, as I told you, only those orbitals, only those electrons will take part in bonding which have half filled orbitals. This fully filled orbital will not take part in bonding. How can this take part in bonding? Can 3 electrons be put here? No, this is not true, right? It cannot take part in bonding. So what will happen here? This is lone pair. This is what we call lone pair. This is what we call lone pair. Okay? This is called lone pair. And these are the orbitals that will form 3 bonds. Right? That will form 3 bonds. That is why in ammonia we have 3 bonds. Along with that we have one lone pair. Right? We have one lone pair here. Okay, great to know that, right? Did you understand that, what I have done here? After that, we will discuss nitrogen with 2 atoms, nitrogen with 1 atom, oxygen with 2 atoms, oxygen with 1 atom. For that, you need to understand this. Have you understood this? Have you understood this? Tell me in the chat box, have you understood this? Lone pair of electrons, and these are the 3 bonds. Example is ammonia, right? Okay. I think you all are sleeping or what? You all are sleeping or what? Oh, ma'am, they don't ask this in paper. Ma'am, we don't want to do this. We want complex question, but the foundation will be weak. Then you will like, okay, ma'am, how do we solve complex questions? Right? Okay. So, nitrogen with 2 atoms. Nitrogen with 2 atoms. Very simple, just like that. Just like that. You have 2s orbital. You have 3 2p orbital. You will have 2 electrons here, 1 electron here, here and here. Okay, so you have 5 electrons. Now, in this case with 3 atoms the hybridization was sp3, right? In this case the hybridization is sp2. The hybridization is sp2. That means you will have 3 hybrid orbital of same energy having 1, 2, 3, 4, plus you will have one pz orbital having 1 electron that will form pi bond, and these 3 will form sigma bond, 3 sigma bonds, 3 sigma bonds. Is it sp2? Wait. Yes. Yeah. These will form, wait. This will not form 3 sigma bonds. Let us see. Okay. This will 1, 2, 3. This will be the part of hybridization. 1, 2, 3, 4. So 1, 2, 3, 4. So these are 2 will form 2 sigma bonds because these are half filled. But this will form one lone pair. This will form one lone pair. So the conclusion is the one nitrogen atom that is linked to 2 other atoms, let it be X, okay? Any X, just a random example, right? So this nitrogen will have one lone pair of electrons. It will form 2 sigma bonds and it will form 1 pi bond, okay? It will form 1 pi bond, 1 lone pair, 2 sigma bonds. Did you understand that, how I draw this? How to draw this? Just by hybridization of nitrogen with, if we have 2 atoms, then the hybridization is sp2. For that, 1 lone pair, 2 sigma bonds and 1 pi bond by sideways overlapping. Okay. So now let us jump to nitrogen with 1 atom. Nitrogen with 1 atom. What do you mean by that? When 1 atom, this is also very simple. Like cyanide. Very simple. So we have 2s. We have electrons here. Then we have 3 here, right? So again, this is 1, 2, 3, 4, 5, right? 1, 2, 3, 4, 5. 5 electrons in 2s and 2p. Now what I will do here? If nitrogen is attached to 1 atom, then it will have sp hybridization. Sp hybridization means this one and this p. That means one py will be left as it is and one pz will be left as it is. And these will form, this will form 2 hybrid orbitals. 2 hybrid orbitals having 1, 2, 3 electrons, right? This will form lone pair and this will form sigma bond. These two will form pi bond. That means it will have this nitrogen will have 1 lone pair, 1 sigma bond and 2 pi bonds. Just example is CN. Example is CN. Did you get that? Understand? Understand? What is sigma? Why are you asking this? You are asking me what is sigma and pi bond. Okay? Understood? Understood? Understood or not? This nitrogen having 1 lone pair, 1 sigma bond and 2 pi bonds. What is the reason? The reason is the hybridization sp hybrid orbital and 2 unhybrid orbital, and with these hybrid orbitals as this is having no half filled orbital, that is why this is a lone pair. Okay? Got it? Perfect. So now next is hybridization of oxygen. Hybridization of oxygen with 2 atoms. Now let us talk about oxygen. So firstly tell me what is the electronic configuration of oxygen. What is the electronic configuration of oxygen? What is the electronic configuration of oxygen? Perfect, perfect. What is the electronic configuration? The atomic number is 8, ma'am. The electronic configuration will be 1s2, 2s2, 2p4, 4, 5, 6, 7, 8. Is this the electronic configuration? Right? This is the 6 valence electron. Perfect. 6 valence electron. Perfect. Bahut badhiya. Very good. So these have 6 valence electrons. So now what we'll do here? 6 valence electrons, 4, 5, 6. Now this is 2s and this is 2p. This is 2p. 2s is having 2 electrons and 1, 2, 3, 4. Like this. This is the filling of electrons. Now what will happen here? Oxygen with 2 atoms. Just a simple trick. Oxygen with 2 atoms. It will form sp3 hybridization. That means it will have 4 hybrid orbitals of same energy, and the electrons are 1, 2, 3, 4, 5, 6. Okay, 6 electrons. 1, 2, 3, 4, 5, 6. 6 electrons. That means here we have 2 lone pairs. Here we have 2 lone pairs and we have 2 sigma bonds, right? So that is the example of water. Water. Yaad aaya? Remember, water. Oxygen is having 2 lone pairs and it is having 2 sigma bonds, bent V shape, right? Okay? So this oxygen will have 2 lone pair and 2 sigma bonds, like this in case of like it is having 2 lone pair and 2 bonds. Now this is very important because even in case of resonance you need to know the how many bonds will be formed by oxygen if it is bonded to 2 atoms, and how many bonds, what kind of bonds will be formed by oxygen if it is linked to 1 atom. Okay? Okay. So now let us discuss hybridization of oxygen with 1 atom. Hybridization of oxygen with 1 atom. With 1 atom, let us discuss that. So oxygen, as you all know, it is having 2s, we have 2 electron here, 2p, we have 4 electrons here, right? We have 4 electrons here, right? The total number of electrons is 1, 2, 3, 4, 5, 6 electrons, right? Okay. So now, here the hybridization is sp2. Along with that, this one will be unhybrid. This will be unhybridized orbital, right? This will form pi bond, this will form pi bond. And we will have 3 sp2 hybrid orbitals, 1, 2, 3. These here sp2 hybrid orbitals, and these will have 1, 2, 3, 4, 5 electrons. So 1, 2, 3, 4, 5 electrons. Now it will form 1 sigma bond here. It will form 1 pi bond with pz sideways overlapping, 1 sigma bond with hybrid orbital and the orbital of another atom that it is bonding with, and it will have 2 lone pairs. 2 lone pairs. Now I guess you have completely understood why oxygen forms two lone pairs and one electron, one pi electron. So you have also gone through. So when oxygen is only bonded to one atom, any atom, let it be X, any atom, it is bonded to one atom, it will have two lone pairs, one sigma bond and one pi bond. Got it? Got it? So I guess why this is so important, because if you know this, you can easily draw the structures of so many compounds, right? Okay, so for example, we have carbonyl group, so why it is like this? Now you know the reason behind that. Why carbonyl group has double bond and it has two lone pair in it. Now you know the exact reason behind that, right? Okay, so any issues till now? Tell me bacha, any issues till now? Perfect, that is clear. Okay, perfect. Now we are going to solve some questions. Let us see who wins. I'll take the name of students who win here, right? These are very easy questions, but they can be asked in your exam, right? This will form the base. Now tell me, how many pi electrons are there in the following molecule? So this is the question. This is the diagram. You can see that. Can you see that? This is the diagram. This is the compound. How many pi electrons? Pi electrons mean one pi bond will have two pi electrons. How many pi electrons are here? A, B, C, D. 4, 6, 8, 10. Let us see how many students have given the answer. How many? Till now, nobody has given the answer. 3 pi, no, they are not asking about bonds. They are asking about electrons. They are asking about electrons, not bonds. B, 6 answer. So many of you are saying 6, so many of you are saying 4 also. Let us see. I know. When you see this for the first time, you will say, ma'am, one pi bond here, and it will form 3 pi bonds, and it will have 6 pi electrons, right? Very simple, ma'am. This is very easy. Answer will be 6, and you will take this. But if I say this is wrong, why, ma'am? What is the issue with this? So now let us see why this is wrong. So guys, as you all know, this will have lone pair of electrons here, and so many you must have studied resonance, but so many of you will study resonance this Thursday with me, right? So many you must have already studied resonance, but so many of you will study resonance this Thursday with me. So now, as you all know, if we have an atom say A and this is B and this is C, right? If this is having lone pair and this is sigma bond and this is pi bond, this is the case of, there were so many cases of resonance. I am telling you this Thursday, if you don't know resonance, you will have I'll have a very amazing lecture on resonance. Perfect lecture. We'll draw the structures from the bases, all the cases we'll discuss. All the PYQs we will discuss in that lecture, right? So guys, this is one example, this is one case of resonance, that is lone pair, sigma and pi bond. So that means resonance will occur here, the electrons will shift here, this will shift here, and because of all that, one extra pi bond will be here. One extra pi bond will be in this resonating structures. So that is why the total pi bonds will be 4 and the electrons will be 8 electrons. And to all those students who don't know how this got shifted, I will teach you this Thursday. Okay, I'll teach you this Thursday. So it will have 8 electrons. The answer is 8. The answer is 8. You don't know, Sat is saying he don't know resonance. Don't worry, that's why I have picked from the very basic. You can, so I'll teach Tuesday, I'll teach inductive effect. After that, Thursday, I'll teach resonance, resonating structures, mesomeric effect. I guess so. In next 15 to 20 days, you will have a very good hold over organic chemistry, GOC. You will have a perfect hold over GOC. After that only we'll jump to chapters. We'll do hydrocarbons, alcohol phenols, aldehyde ketones, and so many conversion, distinguished tests, naming reaction. We'll do all of that thing, right? Okay, so the answer is C. Now, vital force theory of organic compound was proposed by ma'am. This is very, very easy. Ma'am, this is very easy. ABCD, ABCD. Tell me. Tell me. Sakshi, it doesn't matter. It doesn't matter. They have equal respect. Both the lone pair have equal respect. Right? Anyone can form. There is no distinguish. We can't distinguish between which lone pair have formed bond. Right? Yes. Okay. So, what is the answer, Victor? What is the answer? Vital force theory of compounds has given by Berzelius, as I told you in the start of this lecture. It was given by Berzelius. Which of the following compounds have maximum number of pi bonds? Which will have maximum number of pi bonds? Tell me fast. Fast. Which will have maximum number of organic compounds? Which will have maximum number of pi bonds? This is very easy. Very simple. 1, 2, it will have, this is benzene, it will have 3 pi bonds. This will have 3 pi bonds in the ring and 1 pi bond outside, that is 4. This will have 3 pi bond in the ring and 2 pi bond outside. So this is 3, 4, 5 pi bonds, and this will have 1, 2, 3, 4, 5, 6 pi bonds. This will have 6 pi bonds because in triple bond we have 1 sigma and 2 pi bonds. So this is 3 triple bonds. So that means 6 pi bonds. So the answer is B. So the answer is B. Why have you given D? Why have you given D? Because ma'am, we thought this is 1, 2, 3. We thought these are 3 pi bonds. But bacha, triple bond have double 2 pi bonds and 1 sigma bond. That is why the answer is B. Okay? The answer is B. Right? Understood? Any problem? Any problem? Any problem here? Have you liked the session or not? I can't see any likes here. Very disappointed. I can see. Okay. So now next question is number of sp2 pi sigma bonds present in the given compound is sigma bond. Number of sp2. Firstly, ma'am, we need to know. We don't know sp2, sp3. Which carbon atom is sp2? Which carbon atom is sp3? How do we find it out? Simple trick. You don't need to draw all those structures and hybrid orbitals and all that. Simple trick. What was the trick? Calculate the number of sigma bonds. Calculate the number of sigma bonds here. Calculate the number of sigma bonds. So this carbon is having 2 sigma bonds. 2 sigma. This is having actually 3. Arey ma'am, this is not having 2 sigma bonds. There is also 1, 2, 3, 4, 1 hydrogen here. So let me draw this here. Let me draw this here. Let me draw this here. So many of you forget hydrogen. Here also we have 1 hydrogen atom, right? So this is the bond. Here we have 1, 2, 3, 1 hydrogen atom here, 2 hydrogen atom here, 2 hydrogen atom here, 2 hydrogen atom here. So now tell me, how do we calculate sp2? So this carbon atom is having 1, 2, 3 sigma. Sigma, I am not talking about pi bond, I am talking about sigma bonds. So this will have 3 sigma bond, 3 sigma bond, ma'am, 4, 3, 2. This is sp3, this is sp2, this is sp. So that means 3 sigma bond means sp2. So this is sp2 hybridized. This is having 3 sigma bond, sp2 hybridized. This is having 3 sigma bond, sp2 hybridized. This is having 3 sigma bond, sp2 hybridized. This is having 1, 2, 3, 4 sigma bonds, sp3 hybridized. This is sp3 hybridized. Again sp3 hybridized, sp3 hybridized, sp3 hybridized. Okay. Okay. Okay, understood. So, how many sp2 pi sigma bonds? 1, 2, 3. So, answer is C is the correct option. Very good. Yash, very good, very good, very good. Suresh, Ashwarya, Shakti. Okay. Any other student? Why not giving me the answer? What is the reason behind that? Are you not getting? Are you very lazy to give answers. Okay, ma'am, you can teach, but we don't want to use our brains. We just want to sit and relax, take a chill pill. Okay, so now next. In which of the following carbon is sp2 hybridized state? In which of the following carbon is sp2 hybridized state? sp2 hybridized state. Tell me. In which of the following? Okay, C. Perfect, 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 perfect. I can't zoom it in, but I can't zoom it in. Okay, so which of the following carbon is sp2 hybridized? After this, we are going to start IUPAC naming. After this question, we are going to start IUPAC naming. Okay. After this, we are going to start. You know what? I have given like you can actually see 10 to 15. I have combined my 10 to 15 lectures into one lecture. That is this lecture. My 10 to 15 lectures of IUPAC naming, that is combined in just one lecture. You can see the amount of hard work that I have put into that, and so many rules and regulations of organic chemistry of IUPAC naming you are going to learn today itself, from basic to advanced, today only, after this question. Okay, so what is this? Yes, very good. So sp2, this is 1 2 3 4, that is sp3 hybridized. This carbon is having 1 2 3 pi sigma electrons, sigma bonds. So this is sp3 sigma bond, that is sp2. This is having 2 sigma bonds, so sp. This is having 4 sigma bonds, so that is sp3. So the answer is B. So the answer is B. As I told you, bacha, as I told you earlier also, if you have 4 groups, 3 groups, 2 groups. 4 groups means sp3 hybridization. 3 groups means sp2 hybridization. 2 groups means sp hybridization. Just note it down somewhere. If I am drawing this bubble anywhere, if I am drawing this bubble, this cloud, that means the rain of important questions will be there. So this means important thing, something very important, right? So this is very, very important. So now, what is this 4, 3, 2? As I told you, this can be number of sigma bonds or lone pair, or lone pair, or lone pair. Okay, or lone pair. For example, if I say this is water, this is water. So what is the hybridization of oxygen? What is the hybridization of oxygen? You will say it is having 2 sigma bonds plus 2 lone pair, that is 4. So 4 is the number of group. So that means 4 group means sp3 hybridization. Understood? Groups means either sigma bond or lone pair, right? As it is having 2 lone pair and 2 sigma bonds, the answer is 4. 4 means sp3 hybridization. Okay, got it? Got it? Understood? Yes. Amazing. Also one more thing. If I have to draw, if you need to tell me what is the hybridization of this? What is the hybridization of nitrogen in this? What is the hybridization? As we all know, nitrogen is having 1 sigma bond, 1 lone pair. So hybridization group is 2. For second group, we have sp hybridization. So the answer is sp. Understood? How to calculate hybridization of any atom in any structure? Any atom, any structure, you just need to see how many sigma bonds, how many lone pair, and just add on. And if it is 4 sp3, 2 sp, and then 3 sp2. Okay, got it? Perfect, perfect. So now what is homologous series? Homo means same. Homo means same. So this belongs to same family. Homologous series, it's as if my name is Diksha Kaushal. So all the Kaushals in my family, that they belong to my family, right? My parents, my sister, they all have surname Kaushal. Okay, so we all belong to this symbolizes that we all belong to same family. The same case, homologous series belong to, that means they belong to same functional group, same family, But how can we identify it? Just by, if it is written C2H8O, right, and C3H10O. So how do we understand if this belongs to same group or not? So what is the difference in the carbon and hydrogen atom? Carbon and hydrogen atom, the difference is here we have 3 hydrogen carbon atom and here we have 2 hydrogen carbon atom. So there is 1 C and 2 H. So difference is CH2. So in homologous series, there will be a difference of CH2 group. What will the difference? They're very good. Differ by CH2 and it will have 14U. 14U, what is the mass? That is 14U. 12 plus 2, 14U. Right? This is very simple. Okay? Very easy. Right? Chalo. Coming to next. Alkyl group. What is alkyl group, ma'am? Alkene. What is alkene? This is Cn, H2n plus 2. Right? Minus 1 hydrogen, that is Cn, H2n plus 1. This is alkyl group. This is alkyl group and this is a substituent. You will see this is a substituent, right? This will act as a substituent in all the IUPAC names. You will say methyl, propyl, ethyl, so many things. Okay? This is, no, that is not a homologous series. Homologous series, they differentiate by CH2. What is the reason behind that? For example, you have CH3OH. The next family member, this is grandfather. What is the name of father? Father is CH3CH2OH, right? In some families, they put the name of their father after their name, right? So this is the same thing. This is the name of father and this is its own name, CH2. It differs by CH2. Okay? Okay? Right. Perfect. Okay, perfect. So next is now the main thing. Now everyone be ready for the main task of today's class. Okay, I'll start with IUPAC name. I'll draw some structures here. You'll just have to you just need to answer me what is the name, what is the IUPAC name of that structure. If you already know that, if you don't know that, I'll tell you the correct answer along with the rules. What is the rule? What is the rule behind that? Okay. So first let us, I'm drawing these structures. Okay, I'm drawing these structures. Which pen do you want me to use? Which pen do you want me to use? We have these combinations. Tell me which pen you want me to use. Could I use this one? I think this one is a little bright. I think this one is a little bright, so I can use this, right? Okay, perfect. So I'm drawing these structures. Wait. Yeah. So this is CH3, CH2, CH3, CH3, CH2, CH3. What is the answer? What is the answer to this question? Answer the question fast, because if your speed is correct, even my speed will increase, right? If you don't understand at any point, just point out that, ma'am, please repeat that. Okay, ma'am, start from basic. This is a very basic question, very basic. From very basic I have started. Okay, we'll go from simple alkane substituent longest chain to polyfunctional group. From this to this today only, right? Perfect. So firstly, what is our task? We need to calculate here which is the longest chain. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. So this is the longest chain. So firstly, highlight the longest chain. After that, name this, number this. From here, we should number this, ma'am. We should number this from this side or this side. From this side, we get 3. The substituents. Okay. So firstly, select the parent chain, longest chain. Write it down, longest chain. You should select the longest chain. And after that, Even if you don't know I of IUPAC naming, na, today you will get that. Okay, just have trust on me. Okay, so now longest chain and numbering should be, substituent should be given lowest number. Substituent should be given lowest number. So from here also, this carbon will get 3 numbers. So I can start it from here. 1, 2, 3, 4, 5. So the answer is very simple. Answer is, kya answer aayega? What will be the answer? 3 dimethyl. Dimethyl. This is alkyl group. These are 2 substituents, right? Methane is CH4, methyl is CH3. If we subtract 1 hydrogen from alkane, that is alkyl. So this is methyl. 2 methyl, that means dimethyl. 3 dimethyl. This whole is pentane. Now ma'am, what is pentane? Why we have written here pentane? See, for alkane, I am writing this here only. Okay, I am writing this here only. CnH2n plus 2 minus H, that is CnH2n minus plus 1. Right? So, meth means 1 carbon. Eth means 2 carbon. Prop means 3 carbon. But means 4 carbon. Pent means 5 carbon. Right? Pent means 5 carbon. Now tell me, hex means 6 carbon. Hept means 7 carbon. Oct means 8 carbon. Non means 9 carbon. Dec means 10 carbon. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. From the very basic thing, right? This is 1, 2, 3, 4. Number of carbon chain in the parent chain. Number of carbon atom in the parent chain. So here we have 5 carbons. That is why I have written pentane. Okay? Perfect. Perfect. Okay, perfect. Now, next question here is, if you are talking to each other, na, even for 2 minutes, you will lose something. Why? Because for every example, you will have some another rule. Okay, for every single example, you will see one rule is added here. Okay, so now what is this? What is this, bacha? What is this? So now we have one cyclic chain here and one normal open chain here. Ma'am, how should we do the naming here? Okay. Should we consider this as our parent chain or this as our parent chain? So now, understand this point. If you have this kind of case, you will give parent chain to that one which has more number of carbon atoms. So now this has 3 number of carbon atoms and it has 3 number of carbon atoms. If the carbon atoms is equal, so now this also have 3 number of carbon atoms. This also has 3 number of carbon atoms. Okay, this also has 3 number of carbon atoms. So now what you will do here, for same, you will see, you will give parent chain to this one and this will be your substituent. This will be your substituent. This will be your substituent. This is your parent chain. What is the reason behind that? If the open chain is having more number of carbon, it will be parent chain. If the cyclic chain is having more number of carbon atom, it will be the parent chain. If they have same number of carbon atom, then open chain will be the parent chain. So this is the substituent, this is the parent chain. I'll write it as 1, 2, 3 because substituent should have lowest number. Okay, so this is 1 cyclopropyl. Why propyl? Because now this is the substituent. Propane. 1 cyclopropyl propane. Okay? 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 Now, next thing. If it is like this, if I have drawn it like this, CH2, CH3. Now tell me which will get parent chain and which will be the substituent. Again, the thing which is having more number of carbon atoms will be the parent chain. So this will be the parent chain 1, 2, 3, 4. Now the name will be, name in the comment section, name in the comment section. Bacha, once you are done with the IPSC naming, the class will be over. It can be 1 hour, it can be 2 hours. Okay, my task is from basic to advanced level of IUPAC naming for polyfunctional group. I want to take you this to polyfunctional groups. Okay, chain. Yes, open chain will get more number of carbon. More number of carbon means that will be the parent chain. This is the parent chain. So we will write it as 1 cyclopropyl, and this is butane. 1 cyclopropyl butane. Okay. Coming to next. Now you should answer this one. This one is, if you have answered this one correctly, that means you have understood this rule. If you answer this one correctly, that means you have understood this rule. So now tell me, which one should have? Usually what students do, they don't consider number of atoms, they just randomly take one as parent chain. You should not take this as randomly, right? So one having less number of carbon atom is the substituent, more number of carbon atom is the main chain, parent chain. So this is the substituent, this is the substituent, and this is the parent chain. So it will be 1, 2, 3. This is 1-methyl cyclopropane. 1-methyl cyclopropane. Very good. Perfect. Okay. Now coming to next. Very good. Amazing. Now coming to next. Another rule. I am telling you, for every question, for every single question, I have different rule. For every single question, you will have addition of few rules. Okay? That is how we'll do IUPAC naming in just one day. Right? IUPAC naming in just one day. Right? So what is the answer to this? What is the answer? Tell me. You have two double bonds here. Right? So see. Double bond should get the lowest numbering. Double bond should get the lowest numbering. So I'll start off not from here but from here. So this is 1, 2, 3, 4, 5, 6. Right? So how you write double bond? Double bond means alkene. So for alkene, what we say, like this is the parent. The number of carbon atom in the parent chain is 6. So I'll write it as hex. If this was alkane, I would have written it as hexane, right? But now as this is alkene, so I'll write it as hexene. But ma'am, here we have two double bonds. So what I'll do hex first and third. This first one and this third one, from where the double bond is starting, that numbering I should consider. First and third. So I'll write it as 1, 3 diene. Right? Okay. So now, is this right? Tell me, is this right or do I need to correct this? Is this right or do I need to correct this? Tell me. Is this correct or do I need to correct this? Let me see. Everyone is saying hex. Very good. You know what? Ari, very good. Ram Kumar. Very good. Sanvi. Very good. Perfect. So, these students have written what? Why I am saying very good to these two students? Because they have written hexa. So, this A is included if we have multiple bonds. If we have multiple bonds, then we will write A here, right? Then it will be 1A will be added additionally to the number of carbon atoms, okay? If we have, very good, this is hexa, right? This is hexa, and if we have multiple bond, we will add A to the number of carbon atoms. This is pent, then that will be penta. Hept, that will be hepta. only in case of multiple double bonds or triple bonds. Okay, multiple double or triple bonds. Yes, very good, very good, very good. Okay, perfect, perfect. Done. Should I go ahead? Should I go ahead? Perfect. Very good, very good, very good, very good. Should I move ahead? Have you understood this? Have you understood this? Have you understood this? Yes, perfect. Now coming to next. Coming to next. Ma'am, now what else? So 1, 2, 3, 4. So name this compound. Name this compound immediately. Name this compound. Select the longest chain here. Longest chain here. And understand, longest chain, ma'am, longest chain is 1, 2, 3, 4, 5, 6, 7, 8, 9. Should the longest chain have 9? Should the longest chain should have 9 carbon atoms, or it should have 1, 2, 3, 4, 5, 6, 7 carbon atoms? Tell me, what should I select? 1, 2, 3, 4, 5, 6, 7, 8, 9 and 1, 2, 3, 4, 5, 6. 4, 5, 6, yeah, 6. Which should I select? I should select that chain. Longest, I understand that. But I should definitely include my double bond and triple bond in the chain, in the parent chain. So I will rather select this chain. 1, 2, 3, 4, 5, 6 and not this chain. Understood? That should have 6 carbon atom. What is the reason? That parent chain should have triple bond or double bond in the parent chain. If that is possible, I will include, I will neglect 9 carbons and I will choose 6 carbon chain because of double bond and triple bonds present here. Right? Okay, so this is the parent chain. So now let us see what are the substituents. So these substituents are, we have at third position, I have, this is what? This is 1, 2, 3. What is this substituent called? What is this substituent called? It has 1, 2, 3 carbon atoms. This is propyl. This is propyl. And what is this substituent called? 1, 2, 3, 4. This is butyl. This is butyl. Now tell me one thing. एक चीज बताओ. You know, sometimes I speak in Hindi, so I'm not used to of that. That's why. Yeah. Okay. So now this is propyl and this is butyl. Now tell me, which numbering is correct? Should I number it as 1, 2, 3, 4, 5, 6? Now tell me which numbering is correct, blue one or pink one? Which numbering is correct, blue one or pink one? Which numbering? Which numbering is correct? Another rule of IUPAC naming. Another rule of IUPAC naming. Which numbering is correct here? Which numbering is correct here? Tell me. Okay, perfect. Which numbering is correct? Blue one, pink one. Blue one, pink one. Which numbering? I can see. I can't see in the chat box which numbering is correct. Blue one or pink one. Blue one or pink one. Let us see. Let us see. Let us see. Let us see. Okay, see here, if I start off with pink one, I'll have 4 butyl and 3 propyl. And if I start off with the blue one, I'll have, this is blue one, this is blue one. If I start off with pink one, I'll have 3 butyl and 3 butyl and 4 propyl. So as we know, there is another rule of IUPAC naming. Another rule. There are so many rules, ma'am. So many rules, but if you see this lecture by heart, you will learn all this. Okay. The only condition is you should have patience. Patience is the key to success. Okay. That is the only condition here. So we know alphabetical, as you all know, well, you know, when there are board exams, you have given your 10th board exams, the person whose name starts with A will be seated first, whose name starts with D will seated next to A. After that, F, after that E, A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. That's how alphabetical order roll numbers are given to the students by boards, right? That is how students need to sit in the class while sitting in the examination hall, right? That is true. So that is how the same case is applied here also. 4-butyl, B comes first and P comes after that. B is first and then there is P. So we will give priority to B. We will give lowest number to B. Alphabetically we will give the numbering here. So we will rule out blue color here. We will choose pink color numbering here. That is 1, 2, 3, 4, 5, 6. That means this is wrong and this is correct. Okay, this is correct. Right? This is wrong and this is correct. That is 3-butyl 4-propyl. 3-butyl 4-propyl is the correct answer here. Let me see how many students have given the correct answer. Perfect. Bahut badhiya. Very good. Very good. Very good. Very nice. Very nice. So this is 3-butyl 4-propyl, and what is next to that? What is next to that? 3-butyl 4-propyl. 3-butyl 4-propyl, and this is hexane. 3-butyl 4-propyl hexane. Understood? Everyone understood? I'm so sorry for the voice today. I'll surely correct that. I'm so sorry for the voice today. Okay? I'll surely correct that. That is my duty. I'll correct that. Okay? Please manage today. Just today you need to manage. I'll correct that today itself. Okay? Yeah. Perfect. 4,5-diethine. Ma'am, can't we name it as 4,5-diethinyl? No, you can't. No. You have to select that parent chain which is having double bond and triple bonds. Okay? So the main chain will be this only. Main chain should have multiple bonds. Main chain should have double bond, triple bonds. Right? Okay, so yes, Darshana, we can't name it like that. Okay? Yes, perfect. Now coming to next question. Now you have another question. Okay. So this is Br, this is Cl, this is F, and this is So many students are eagerly waiting. Ma'am, we want to answer. Ma'am, we want to answer. Right? So let us see who answers this. This is very easy. You just need to pick one longest chain, parent chain, and after that name the substituent alphabetically. Also choose that numbering which is giving lowest number to more substituents. Like for example, if we choose this numbering, so firstly choose the longest chain. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. From this to this we have 10. From this to this, right? From this to this we have 10 atoms in the parent chain. So we'll select that, right? We'll select that. After that. What should we do, ma'am? Should we select it as 1, 2, 3, 1, 2, 3. 3 we have methyl, and here we have 3 we have bromo, and then 4 we have fluoro, then 6, 1, 2, 3, 4, 5th we have chloro, and after that 7th we have nitro. So I'll select that numbering which is giving substituent the lowest number. Here also it is giving 3, here also it is giving 3. But here it is giving numbering to more number of substituents. That is why I'll choose this numbering 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? So now write down. Let us see. 3 bromo, 5 chloro, 7 nitro, 4 chloro. Okay, perfect. So now this is bromo, this is fluoro, this is chloro, this is nitro, this is methyl. Right? So name this alphabetically. That means firstly you will write 3 bromo. After that you will write not. Some student might write this as 3 bromo 4 fluoro. No. You will write 3 bromo 5 chloro, because A, B, C, D, E, F alphabetically you have to write it down. 3 bromo, then we have 5 chloro, then we have 5 chloro, then after that we will write 4 fluoro, 4 fluoro, then after that 4 fluoro, then we have 8 methyl, 8 methyl, and after that we will write 7 nitro, 7 nitro, and this is decane. This is decane. Understood? It was just the game of alphabets, right? Alphabets. Okay? So many, I am telling you, you will find this very easy, but I am telling you, students do mistake in such things. They do mistakes in such things. Why so? Because in hurry, in the panic of giving exam, what they do is, they write it as 3 bromo, 4 fluoro, then pata nahi 7 nitro. They do things like this. Because they are so anxious while sitting in the exam hall. So you just need to focus on these little things. Okay? Okay? Right. So next is another rule. Wait. 1, 2, 3, 4, and this. Yes. And after that, yes. Another rule. One new rule here. Okay? One new rule here. 3 bromo, 5 fluoro, 4 fluoro, 8 methyl, 7 nitrodecane. Perfect. Very good. So now what is the name? What is the IUPAC name of this compound? What is the IUPAC name of this compound? What is the IUPAC name of this compound? Firstly, we need to select the longest chain. Here I am going to tell you how to name complex substituents. Complex substituents, ma'am, that means. So, what is the longest chain here? Longest chain is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, how should we number it? We should give the substituent the lowest number. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Now, very good. Now, bacha, what we are going to do now? Third position have a substituent. That is a complex substituent, right? That is a complex substituent. How should we answer? How should we name the complex substituent? We are going to understand that. Okay. So now, firstly write the name as this is 10 carbon atoms. Write it decane. Write a decane at the end. Now you have substituent in third position. So what you will do? For complex substituent, you draw a bracket here. This is the bracket. Okay? You draw brackets here. Right? For complex substituent. Now how should we name the complex substituent? This is, just forget this. Understand this? Just forget about this. When you are naming the complex substituent, just forget for a minute, just forget about this thing. Like sometimes during festivals, you forget about your NEET exam, right? So the same way, forget about this thing. Okay. So now, this is the main focus point for you. Now, name this. How do we name this? Select in the similar manner. Select the longest chain here. The longest chain is 1, 2, 3. So this is 1, this is 2, and this is 3. And 1, 2, 3. What you have done? You have just forget about this longest chain and only focus on this substituent, right? This substituent is having. Now name this substituent. This is 1, 2, 3. This is the longest chain for the substituent. That means, and this is having 2 substituents further. So that means it is 1, 1 dimethyl, 1, 1 dimethyl, 1, 1 dimethyl. I am erasing this. 1, 1. 1, 1. 1 position methyl, 1 position methyl, 1, 1 dimethyl. And what is the longest chain of this substituent? That is 3 carbon. That means propyl. Now, why I have written propyl? Because this is a substituent. This is a complex substituent. So, that is why 1, 1 dimethyl. This is the substituent. Right? So, this is 1, 1 dimethyl propyl. Bracket close. And after that, I will write. decane. After that, I will write decane. So have you understood 1,1-dimethyl propyl decane? Right? Have you understood 3? Count. Very good. Have you understood this? Tell me, have you understood this? 1, 2, 3, 4, 5, 6, 7, 8, 9. 7, 8, 9, 10. 10 is the longest. Wait. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Arre, yeah. Okay. Got it. Now what you do here? Now, which student has pointed this out? Aishwarya, yes. Omar, very good. Yeah. The longest chain was that. Yes, the longest chain was that. But now as I need to tell you here, I need to tell you the complex substituents. What I'll do a correction here. I'll just write this chain as this much. Okay. This chain is just 7 carbons. Okay. This chain is just 7 carbons. Wait. 1, 2, 3, 4, 5, 6, 7. Wait. Let me correct this. I have to mold the question according to the answer. Right? 1, 2, 1, 2. So in this case, you will have because here I need to tell you about the 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8. Yes, I think this is perfect. 1, 2, 3, 4, 5, 6, 7, 8, 9. This should be nonane. And this is 5. Now is this correct now? Perfect? Yeah. You have that was right, because the previous question that I discussed, that was having another longer chain, because it was having a longer chain including this thing, right? So in that case, that thing was correct, choosing the longest chain first and avoiding the complex substituent. But here in this case, I can't find any longest chain. Longest chain is having only 9 carbon atoms. Otherwise, it will have 1, 2, 3, 4, 5, 6, 7, 8. Right? Okay. So in this case, the longest chain is 9 atoms. Okay. So I have corrected it. Right? Yes. Okay. Sure. So firstly, you need to understand in the previous question what we did was, I draw, I think this kind of compound I have drawn, right? This kind of compound I have drawn. 1, 2, 3, 4, 5, 6, 7, 8. This kind of compound I draw, right? So for this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So many students have pointed out, and that was actually correct. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This was the longest chain for the previous question. So we need not know any complex substituent. We need not name any complex substituent in that. In that case, that was 3, 3-dimethyl, 4-ethyl, and then we have dodecane. Okay. Yes, I think so. That is clear to you now. Right? Is that clear to you now? Yes. Perfect. Is this clear to everyone now? But just give me a minute. Just give me time. Okay, I'll surely advise you about that. Firstly, focus on this. Okay, Now, this was all about simple alkyne substituent thing. Now we will discuss about functional groups. Okay, we'll discuss about functional groups. So with functional groups, you have alcohol, ketone. So one by one we will discuss all the functional group, and after that we will discuss about polyfunctional groups. So firstly, the first question here is CH3, CH2, CH2OH. Now tell me, very simple is this. This is very simple. What is the name? What is the answer to this? What is the answer to this? Very, very simple. Easiest. What is this? This is OH. OH means this is alcohol. Alcohol has the word root for alcohol is OL, right? So this is 1, 2, 3, 4. So now we have parent chain butane 1 ol. Why 1 ol? Because this is 1, 2, 3, 4, right? Okay? Okay? Yeah. So this is butanol. Next is CH3, CH2, CH2, OCH3. Now what is this? This is ether. What is this? This is ether. Ether, right? What is this? This is ether. How do we name this? 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 Yes. How do we name this? Alkoxy alkane. This is a hint. Alkoxy alkane. Now what is the alk part? What is the alkoxy part? What is the alkane part? Tell me this. What is the methoxyethane? Okay. Okay, perfect. So now we know alkoxy alkane. Alkoxy alkane, alk part is having less number of carbon, and alkane part is having more number of carbon. Very simple. Alkoxy part is having less number of carbon, right? And alkane part is having more number of carbon. Alkane part is having more number of carbon. So the answer will be more number of carbon. More number of carbon. This will be alkane part, and this will be alkoxy part. So this will be methoxypropane. So this is the methoxypropane. Okay. Methoxypropane. Very easy, ma'am. Very easy. Is this right? Very easy, ma'am. We know this. Ma'am, let us jump to another question, right? Okay. So very easy. Alkoxy alkane, simple. Let us jump to another question. So this is very easy. This is the most easiest question of today. Most easiest question of today. Now, what is this? This is aldehyde group. What is this? This is ketone group. For ketone, we use on. For aldehyde, we use al. And this is 1, 2, 3, 4. Right? And this is 1, 2, 3. Some of the students write it as propanol. Right? What is this? What is this? We have included this. We have to include this. This is 1, 2, 3, 4. This is butanal. Butane ya vanal. Butane vanal. Butanal or butane vanal. Right? Oh, very nice. Gopika ma'am, yeah. One of my dearest friends. So this is 1, 2, 3, 4. So this is 1, 2, and I'm telling you, when I'll teach you polyfunctional group na, so Baswa sir, Shreyas sir, and Gopika ma'am have given a trick to you to remember that series, that priority series. Okay? So they have made a trick for you. We all have made a trick for you. So I'll tell you which person has given which line, right? Okay, so that will be interesting for you to know how your teachers used to learn priority list. Okay, so now this is 1, 2, 3, 4. This is butane 2-one. Okay, you can also write it as butane one, right? But specify as 2. Okay, specify it as 2. Okay, right, perfect. Chalo. This was, ma'am, very easy. Now let us jump to some difficult questions. This is also actually easy. What is the answer to this? What is the answer to this? And what is the answer to this? What is the answer for this? What is the answer for this? What is the answer for this? What is the, yeah, you are excited? Yeah, at making tricks. Yeah, yesterday only I got to know that. Yesterday only I got to know she makes very funny tricks. Okay, so CH3, CH2, COH. Okay, CH3, CH2, COH. This is propanoic acid. 1% say, is this difficult? Lol. Right, yeah. This is not difficult. Of course, this is not difficult. How you find this difficult? Now, what is the answer to this? What is this functional group? The functional group is acid halide. This is a derivative of acid. Tell me the naming for this. What is the naming for this? No, this is propanoic acid. You need to include this carbon. You have to include this carbon. Okay? The carbon of that functional group is included in the numbering. Okay? No, you can't write ethanoic acid. Ethanoic acid is CH3COH. Okay? Methanoic acid is HCOH. Right? So you have to include the carbon of that functional group in the naming. Similarly, I have included the carbon of this functional group in this naming. Right? You have to include that. You have to include that. This is not ethanoic acid. Okay? Yeah. So what is this? This is acid halide. What is this? This is acid halide. So what is the name for this? The name for this is oil chloride. Oil chloride. Right? Oil chloride. You massage your hair now with oil. So this is oil chloride. So what is this? 1, 2, 3. 3 carbons. So this is propanoyl chloride. Okay? This is propanoyl chloride. The number of carbon atoms propane, and then the name for this is oil chloride, because this is Cl, so here is chloride. Okay? This is acid halide. Okay? Perfect. Now next is you have CH3 CO, just write CH3COO C2H5. Now what is the answer to this? What is the answer to this? These are the basic IUPAC naming of functional groups. So many students have already forgotten that. So what is this, ma'am? This is ester. This is ester. What is the name of this compound? What is the name of this compound? Definitely there will be exceptions. I'll go to that. I'll go to all the exceptions today. Okay? That will be a very interesting part. That is going to be a very interesting part. What is the name? Okay. So what is this? Alkyl alkanoate. Right? This is alkyl alkanoate. What is the alkyl part and what is the alkanoate part? What is the alkyl part and what is the alkanoate part? What is the alkyl part and what is the alkanoate part? What is the alkyl part? Ethyl ethanoate. Very good. Alkyl part is that one which is with oxygen atom, and this is without oxygen atom. This is without oxygen atom. Right? So how would we write that? This is with oxygen atom. Right? This is the alkyl part. This is alkyl part. And this is without oxygen atom. This is alkanoate part. This is alkanoate part. So how will I write it as? This will be written as ethyl ethanoate. Some students write it as ethyl methanoate. But when we include alkanoate, in alkanoate, this carbonyl group carbon is also included. So this will be ethyl ethanoate. Okay? What if this is C3H8? It's 7 yeah. Okay. Now, tell me what will the answer? The answer will be, this is alkyl part. So this is propyl ethanoate. This is propyl ethanoate. Okay. This is propyl ethanoate because this is 3 carbons, this is alkyl part and this is alkanoate part. Okay, propyl ethanoate. Okay, so what if this is, why I am saying this? Because sometimes they ask these simple questions in reactions. This is asked in the reactions and you don't know how to name ester. Most of the students don't know how to name ester, ether. They just get puzzled in this. Okay, so if this is C, I am not writing hydrogen atoms here. Okay, now tell me what is the name. Now tell me what is the name to this question. What is the name? So, this is, with oxygen atom, we have alkyl part. This is alkyl part. This is alkoxide part. So, this is ethyl butanoate. Okay, this is ethyl butanoate. Okay, perfect. Okay, done. So, should I move ahead? Phenyl is ethyl. Yes, I'll come to that. I'll definitely. Yes, definitely you can get ethyl benzoate. Yes, Kavita. Yes, you can write it. Perfect. So now we have next question. Next question is very simple. You just need to know the name. What is the name of this compound? Now tell me what is the name of these two compounds. What is this? What is the name of this functional group? This is amide functional group. Okay, this is amide functional groups. So how do we write amide functional group? This is a acid derivative. This is acid derivative. So how do we write it? Tell me bacha, how this is amide. This is anhydride. So how do we write it? It's very good. This is 2 carbon here. For that we have ethane. And this is amide group. So we'll write it as ethanamide. Okay, this is very simple. Ethanamide. Okay, alkane amide, that is ethane amide. Okay, perfect. Okay, now coming to next, you have this anhydride. So for anhydride, what you do is, you think about the acid that it should have drawn from. Okay, so this is from an acid that is CH3COOH. Okay, again there was an acid CH3COOH, and from here water extracted out, right? Minus water, we have this anhydride. Okay, we have this anhydride from ethanoic acid. So the answer to this will be ethanoic anhydride. Okay, the answer will be ethanoic anhydride. Okay, ethanoic anhydride. No, ethanoic. The acid from where it has drawn. You just need to name that acid. That is ethanoic acid. In place of acid, write anhydride. Okay, in place of acid, write anhydride. Okay, right? Perfect. Ethanoic anhydride. 2 times, you don't need to write ethanoic 2 times. So write it 1 time. Okay, ethanoic anhydride. Okay, now coming to next question. Now something interesting is coming. On your way. Yes, something interesting is coming on your way. Now what is this? Polyfunctional group. So they can ask you some questions where you will have this kind of numbers, like there will be CH3, CH2, OH, CH2, COH. Now this is a polyfunctional group. Okay, now it can also have NO2, right? So now you need to know the priority. which functional group, which is the main functional group. This is a polyfunctional group compound. It is having so many functional groups, right? So now you need to know which functional group is the main functional groups. For that, you need to know the priority order. Okay, for that you need to know the priority order. For example, you are given this thing. For example, you are given CH3, CH2, CH2, C double bond O, CH3. Right, and here it is OH. Now you have ketone and you have alcohol. Now what is the priority order? If you don't know the priority order, you won't be able to solve these kind of questions. Okay, so for that you have this is the priority order. Now we all teachers have made a trick for you, right? Combined trick for all the teachers. So let's see. So as the Christmas season is going on, so Baswa sir added, so we should write it as cute Santa, right? Your cute Santa, bubbly, fatty, cute Santa. That Santa is going to give you gifts, right? We are your Santas, is it? No. So cute Santa, he is going to give us gifts, right? So there are two festivals. First is Santa, that is Christmas, that is cute Santa festival, and cute Santa and Easter. Okay, Easter holidays, you celebrate Easter holidays, right? Okay, so cute Santa and Easter, so there is Christmas celebrations going on. And what you do, there is a girl named Hallie ate chocolate ice cream. So now what happens? Cute Santa and Easter. Cute Santa and Easter. So there are celebrations going on, right? Tomorrow is Christmas. So cute Santa and Easter. Hallie ate chocolate ice cream. So for celebrations, what Hallie did? Hallie ate a lot of chocolate ice creams, you know, vanilla, chocolate ice creams, hot chocolate. She's eating all these things. Hallie ate chocolate ice creams. And there was a king named Edward. Edward King arranges the amazing event. You know what happened that day? There was Christmas and there was Easter. Okay, so in that Hallie ate a lot of chocolate ice creams. Where she ate a lot of chocolate ice creams, when Edward King arranges the amazing event. So you know what? I should also tell you one trick of Gopika ma'am. She said, I actually forgot it. I think I'll ask Gopika ma'am to comment it down. She was saying some cat, a cat Iso. Her cat name was Igno, pata nahi Iso. I don't know, that was Isgo something. The cat name was Isgo. So she gave me a trick that was a very angry cat Isco. Something like this. A very angry cat Isco. I don't clearly remember that. Let me see. Oh, Gopika ma'am is, we need to know what Gopika ma'am has given for you. Okay, so let me see. Gopika ma'am has given a trick for you. Let me see. I'll find that for you. Yeah. And have a cat in go. So that was Gopika ma'am's trick. So let's write it here. And have. She said I have also included this here. And have a cat in go. It's a cat name, right? So you can learn this by any trick that you want. If you have some good trick, write it in the comment section, right? So any cat, any trick you can give me, so I'll teach all the students that ice cream may be put by Gopika ma'am. Yeah, she loves ice cream. She loves ice cream. That's why she. This is a trick by Baswa sir, right? This is a trick by Gopika ma'am. Right? Totally your choice. Whatever you feel like, you can learn this by that method. Okay. So cute Santa and Esther, Hallie ate chocolate ice cream, or and have a cat igno. Edward King arranges the amazing event. Now you need to. Now back to the work, back to the work, back to the work. Eat ice cream. Oh no, is this winter? Oh, in winter we love ice creams. Ice creams are supposed to be eaten in winter. We ate ice creams in winter. Why? So because we love that, right? Who also love ice creams in winter more than summers? I love ice creams more in winter. I crave for ice creams more in winter than in summers. I don't know. I never get cravings of eating ice creams in summers, but in winters I'm like, I need ice cream. In summers I want chai, I want tea, coffee, hot coffee, right? Okay. Okay. So now coming to next. So have you learned this? Have you learned this priority order? So now this is carboxylic acid. This is sulfonic acid. Acid anhydride ester, that is COOR, COOR. This is acid anhydride, that is RCOO. RCOOCOR, and this is acid halide, that means RCOCl. This is amide, that means RCONH2. This is cyanide, that means C triple bond N. Isocyanide N triple bond C. And this is aldehyde, that means CHO. Ketone means CO, and alcohol means OH. Thiol means SH, amines means NH2, and ethers means ROR. So now, if you don't want to learn it through any trick, this is a very simple method to learn this. That is, firstly, carboxylic acid. Then there will be derivatives of carboxylic acid. First there is the king here is carboxylic acid. Carboxylic acid, then there will be derivatives of carboxylic acid, and after that, firstly carboxylic acid, derivatives of carboxylic acid, and after that start off with triple bond, then double bond, then single bond. Here we have triple bond functional groups, then we have double bond functional groups, then we have single bond functional groups. So the trick is carboxylic acid, after that derivatives of carboxylic acid, then triple bond functional groups, then double bond functional groups, then single bond functional groups. Okay, so you have 2-3 things. Okay, thank you. Understood? Okay. So now we are going to the main thing. So I am going to draw some structures here. CH3, CH2, CHOH, CH2, COOH, right? And another is this one, right? So name this. You're going to name this, okay? Every question I'm going to give you some few answers, like if alcohol here is acting as a substituent. Why alcohol is acting as a substituent? Because in priority order, this is the main priority and this is not the main priority. So this is the king here, this is not the king here. So this is the substituent here. So we need to name this according to the king. 1, 2, 3, 4, 5. So now, when alcohol is the main group, then it is ol. The suffix is ol, right? But when alcohol is the substituent, then we write it as 3-hydroxy, and this is pentanoic acid. Okay, pentanoic acid, right? Okay. Is this clear? When alcohol is acting as a substituent, the name is hydroxy. The prefix is hydroxy for alcohol when it is acting as a substituent. Now, second is 1, 2, 3, 4, 5, 6, 7. and this is NH2 and this is OH. Now tell me which is the substituent and which is, I am not going to draw hydrogen here, which is the substituent and which is the main group here. Which is the substituent and which is the main group here. Which is the substituent, which is the main group here. Which is the substituent and which is the main group here. This is amine, this is hydroxy. Let us jump to this. This is amine is here and aldehyde and hydroxy alcohol is here. Amine, alcohol. That means alcohol is the main group and amine is the substituent here. Amine is the substituent here. So I'll write it as substituent and this is the main group. So we will number it as the main group. Okay. So 1, 2, 3, 4, 5, 6, 7. Now tell me what is the name? What is the name? What is the name? If amine is acting as a substituent, the name given to it is amino. The name is amino. 5-amino heptane 3-ol. This is the correct IUPAC naming. 3-amino, no. Here should be 5-amino. Here should be 5-amino. You have just forgotten this. You have taken this as a substituent. This is not a substituent. You just need to you need to have less number of substituent and longest chain. The longest chain here is 7 carbons. For that you need to start the numbering from here, not from here. Okay. So the answer is 1, 2, 3, 4, 5, 6, 7. This is the numbering. Okay. 5. No. Not nitro. Why have you written nitro? This is NH2 group. Amine group. When amine group is acting as a substituent, the name is amino. The name for that substituent is amino, not nitro. This is not NO2 group. This is NH3 group. NH2 group. Okay, this is amine group here. Right? Okay, so now next is Now tell me what is the name for this? What is the name for this? Now you need to know firstly which one is the priority functional group. You have ketone, you have amine, you have alcohol. Which is the priority functional group here? Which is the priority functional group here? Okay, Shreyas sir, come here. So, which is the priority functional group? Tell me. I can't see anything in the chat box. Ketone, yes. Ketone, this is double bond function group. This is single bond. This is single bond function group. So, if you don't remember the trick, you need to know firstly carboxylic acid, then acid derivatives, after that triple bond, then double bond, then single bond. So, double bond is having the more priority here. So, double bond is having more priority. So, I'll write it. This is the main group and this is substituent and this is substituent. Now, the question come here is, how should I number this? Should I number it as 1, 2, 3, 4, 5 or 1, 2, 3, 4, 5? 1, 2, 3, 4, 5 or 1, 2, 3, 4, 5? Which is the correct answer here? Okay, so this is 1, 2. This is amino. The substituent name is amino. The substituent name is hydroxy. So as we know, alphabetically, this is lower number. So it will be 1, 2, 3, 4, 5. So now what will be the answer? What will be the answer? What will be the answer to this? What will be the answer? Perfect. What will be the answer? The answer will be 2 amino and 4-hydroxy. I want to see it in the chat box. What is the answer to this? 2 amino, 4-hydroxy. And what is the name for this? What is the name for this? Pentane 3, oxo, keto. What is the name for this? What is the name for this? As this is the main function group, so this will be one, right? As this is the main functional group, so the answer will be one itself. O-N-E, ketone, one. Why? Here we have not written oxo, we have not written keto, we have not written formyl. Why so? Because it is the main functional group here. So the answer is 2 amino. Let me see 2 amino for hydroxypentane 3 on. Perfect. Okay. Now coming to next question. Coming to next question. Coming to next question, let me write this here. CH3, C, double bond O, CH2, CO, OH. Now what is the answer? What is the answer to this? Now you have one carboxylic acid and the other is ketone. Now ketone is the substituent here. Ketone is the substituent here. If ketone is the substituent, how do we write it? The numbering will start from 1, 2, 3 and 4 and ketone is the substituent. Remember this. If ketone is the main functional group, the answer is on as a suffix. But if it is acting as a substituent, the prefix is either oxo or keto. I am saying either oxo or keto. Both are correct. Either oxo or keto. This can be written as 3-oxo, 3-oxo, 3-oxo. Then this is 3-oxo, butanoic acid. 3-oxo-butanoic acid, or we can write it as 3-keto-butanoic acid. Butanoic acid. Okay, 3-oxo-butanoic acid, 3-keto-butanoic acid. Okay, understood? Understood? 3 amino, perfect. 4 amino, this is this only, na ma'am. 4 amino, 2 hydroxy, pentane, 3 on. Wait. No, bacha, it will be 2 amino because this should be written alphabetically. This is amino and this is hydroxy. A comes first, so I am writing it as 2 amino, 4 hydroxy. Not 4 amino, 2 hydroxy. Okay? Okay? Yeah. So now either this or this. Both are correct. Both are correct. Both are correct. Either 3-oxo or 3-keto. Either 3-oxo or 3-keto. That both can be written in the option. Both are correct. But if you have to choose between these two, this will be more correct because oxo is also used for aldehyde. Oxo is also used for aldehyde, but both of these are correct. Okay? Yeah, both of these are correct. Now, coming to next question. This is going to be a fun session from now because now the questions are really they are going to be very important question, like the question tricky ones from where you will start to feel okay, something dangerous is coming, but okay, fine, don't worry. After this, after 1 hour, you will easily crack all the IUPAC naming. Okay, so now we have 2 functional groups. One is carboxylic acid and the other is aldehyde. We know carboxylic acid is the king. That means, king means this is, just remember this. Very important thing. I am going to speak now. Very important thing. Now, if I name this, can I include this aldehyde in the main parent chain? If I start off by this 1, 2, 3, 4, 5. I cannot include CHO group in the parent chain. I am not able to do it. Why so? Because if I include this CaOH group will feel left out. Because either this can be 1, 2, 3, 4 or this can be 1, 2, 3, 4, 5. We can only go one way. We can't go both directions, right? So that is why I have to choose this chain. If I choose this chain, this CHO group is the substituent. Now understand this. Aldehyde group is the substituent. Yes, we know that. Why? Because carboxylic acid group is here. That is why CHO group is the substituent. Understood? Perfect. Now, it is a substituent, but CHO group is not included in the parent chain. There are 2 options. Okay? There are 2 things. Either CHO group will be included in the parent chain or either CHO group will not be included in the parent chain. I'll just draw one box here. I'll make a cloud here. And this is very important line. Very, very important line. Mark this, very, very important. Most important thing. Right? So, if aldehyde group is acting as a substituent. If aldehyde group is acting as a substituent. Write it. Aldehyde as substituent. As substituent. Aldehyde group as substituent. There are two cases. There are two cases. Either that CHO group will be included in the parent chain or it will be excluded in the parent chain. If it is included in the parent chain, the name is, if it is included in the parent chain, the name is oxo. Very, very important. Most of the student gets confused in this. If it is included in the parent chain, that the name is oxo. If it is not included in the parent chain, the name is formyl. The name is formyl. Understood? If aldehyde group is not acting as a substituent, the answer is Al. Al. It's simple. But if aldehyde group is acting as a substituent, then either oxo or formyl. Oxo only if that is included in the parent chain, and if it is excluded in the parent chain, the answer is formyl. Okay? Yeah, cloud means important. Cloud means most important. So now what I'll write here, this is excluded from the parent chain. That means this is 3-formyl pentane 1,5-dioic acid. Okay? 3-formyl pentane 1,5-dioic acid. Is this correct? 3-oxo. Oh, no oxo here. No oxo, bacha. No oxo here. Why I have not written oxo here? Because oxo is written if aldehyde is included in the parent chain. Here aldehyde is not included in the parent chain. So here it will be formyl, not oxo. Okay? It will be formyl, not oxo. Oxo is written when aldehyde is included in the parent chain. Okay, let me take another example for that. If you are given this question, if you are given this as CH3, no, let it be COH, CH2, CH2, CHO. Now here, understand, here it will be 1, 2, 3, 4. And here, parent chain, in the parent chain, this aldehyde is included, right? This is acting as a substituent because we have carboxylic acid here. So this is the twin, this is the king, this is not the king, right? So that is why this is acting as a substituent. But now this substituent is included in the parent chain. That means we will write it as 4-oxo-butanoic acid. Butanoic acid. Understood? Have you understood the concept of formyl and oxo when aldehyde is acting as a substituent? Okay, perfect. Okay, great. So now next thing that we are going to do. Okay, perfect. Next we are going to do. Okay, tell me. If I write it as 1, 2, 3. Is this correct or not? Tell me, students, if this is correct or not. This is 1, 2, 3. So I'll write it as 3-formyl propanoic acid. 3-formyl propanoic acid. Is this correct or not? Tell me, students. I know this is correct. Perfect. This is correct. But is this correct or not? 3-formyl propanoic acid, is this correct or this is not correct? What do you think? Yes, ma'am. What do you think? Is this correct or not? Students, so see. So in this numbering, in this 1, 2, 3 numbering, I have intentionally not included CHO group in the parent chain. I have not included it. The parent chain is of 3 carbons now. That means now this aldehyde is acting as a substituent, but it is not included in the parent chain. So the answer will be 3-formyl propanoic acid. Okay, so this is 3-formyl propanoic acid. Got it? This is no. This is also correct. This is also correct. Both of these are correct. Depends. Here I have intentionally not included CHO group in the main chain. Here I had no choice. Here I had no choice but to exclude CHO group from the parent chain. Here I had choice. So in the exam, you can be given this option or this option. You will prefer this option. This option will be preferred. But if this option is not given to you, then you will correct this answer. Okay? If this answer is not given to you, this will be correct. Depends if they have included or not. Okay? Okay? You have understood why both of these are correct? Why both of these are correct? What if both options are? If both options are there, this is correct. If both options are there, this is correct. Okay? If both options, then this is more correct. But if this is not given, then this is correct. Okay? Understood? Understood everyone? I'll solve your problem of eco. Don't worry. Trust me on that. Okay? Yeah. Now, okay. Now coming to next. Yes. Now tell me what is the answer to this? What is the answer to this? Now you have triple bond and this is double bond. We know carboxylic acid derivatives, then triple bonds, double bond, single bond. That means here you will give the priority to this group. This is the priority and this is the substituent. This is the substituent. So now how will you write it? How will you write it? How will you write it? This is the substituent. This is the priority group. This is the priority group. This is the substituent. Substituent. Ketone is the substituent. Now, if ketone is the substituent, what is written? If ketone is the substituent, we write it as 1, 2, 3, 4. This is 1, this is 2, this is 3, this is 4, this is 5. We write it as 4-oxo, pentane, 1 nitrile. So remember this is the priority group. This is the priority group. If cyanide is acting as a priority group, the name given to it is nitrile. The name given to it is nitrile as a priority group. Okay? As a priority group. Perfect? Okay. Tell me, should I move ahead? Should I go to the next question? Have you understood this? This is the substituent. Substituent for substituent, it is oxo. And understand, ketone is always included in the parent chain. Always, it will be included in the parent chain. Okay? It will always be included in the parent chain. Now, next question. Now, this is the most important question. Be ready for this. I want to see how many of you are giving the right answer. I want to see how many of you are giving the right answer. This is CHO, this is CHO. Okay, so this is 1, 2 and this is CH2, this is CH and this is CH2. Now answer this. Tell me. This is very important question. Very important question. Most important question of today. Let's move on. From whom? Okay, so this is CHO. Now, what you will do? You will think, okay ma'am, there are 3 CHO groups. I want to see how many of you answer this correctly or not. Correctly or not doesn't matter. Just answer this question. I want to see how many of you try to answer this. How many of you are trying to answer this? So there is one answer, that is propane, 1, 2, 3. Very good. Perfect. There is another answer, that is Jesus King, propane, 1, 2, 3, carbaldehyde. Wow, amazing. So now these 2 students have given the correct answer. So now many of you have, maybe some of you have thought that this can be 1, 2, 3. This can be 1, 2, 3, 4, 5. Ma'am, but now this CHO group is not included in it. So you can write 3 not included means you have to write it as formyl, 3 formyl, 3 formyl, pentane 1,5 diol. How many you have thought about this? How many you have thought about this? Right? If you have never done this question, you might have thought about this, right? But this is wrong. Why? Because of symmetry. Because of symmetry. Why symmetry? Symmetry means if there is similar group, these are twins, these are triplets, right? Not twins, these are triplets. They are from the same family, like your siblings. You have to treat all the kids in the same manner, right? So it's not ki this is the elder one, this is the youngest one, and this is the middle kid, right? So the middle one always like ki nobody cares about that kid, and the elder one is giving importance because he's the eldest, and then the younger one because he is a little baby, so he's given the importance. But the middle one is like, am I the elder or am I the youngest? What should I do, right? So this is not happening in IUPAC naming. These 3 are from the same family, from the same parents, so they will have the same priority. They will have the same priority. Here we have no, we don't do such things in IUPAC naming. Okay, why so? To maintain the symmetry. Okay, tell me, how many of you are younger ones, elder ones, or middle ones? I am the youngest. I am the younger one. I am the younger one. You are the younger one, elder one, or the middle one? Let's see. Let's see. Which party do you belong to? So now, because we have to give these 3 kids the same priority, that is why I will not name either of them. It's like parents have 4 tickets. They have 4 tickets. Mom, dad, and 2 kids. But they have 3 kids. Now, which 2 kids should they take? Right? So that is why what they have decided, they will not take any kid with them. The kids will stay at home and they will go and watch the movie. Okay? So this is 1, 2, 3. They will go and watch the movie. These kids will stay at home. Okay? These kids will stay at home. Let me see, there are so many. Youngest, only child have different swag. Only child have a very different. Single child have another level of swag. They have another level of swag, because I know that, okay, we are the only one here. Sometimes they are not even given the priority, but sometimes they are given the priority. So yeah, but I feel sad about the middle child. I really feel sad about the middle child. They don't know if they are the youngest or the eldest. They are treated as, okay, side ones, right? Is it? Yeah. So but we don't do such things in chemistry. So this is 1, 2, 3. So this is main chain is propane, and this is 1, 2, 3 tri. There are 3 aldehyde group. And listen to this. Listen to this. This is also very important. I am making a cloud here. I am making a cloud here. If what is the question? If CHO group is attached to ring, or it is not included in the parent chain because of symmetry, then we write the name as carbaldehyde. We write the name as carbaldehyde. There are 2 conditions to carbaldehyde. First is, it should be directly attached to any ring. It should be directly attached to ring, or it should not be given the parent chain. It should not be included in the parent chain because of symmetry. Okay? Then only we write it as tricarbaldehydes. Okay? It got fatty by eating carbs. You eat carbohydrates and you get fat, right, on your body. Right? You eat a lot of wheat, you are eating chapatis daily, then you'll get fat. Right? So that is how it has eaten carb, and it is now the fatty function group. Okay? Okay. So now coming to next. we have, what is the answer to this? 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 What is the answer? Now you have the parent chain will be 1, 2, 3, 1, 2, 3, right? You can't include two CHO groups and exclude one, right? This is done. Now, let us see. Should we write it as propane 1, 2, 3 tricarbaldehyde? No, we can't write it as tricarbaldehyde because this is not carbaldehyde. This is CH2CHO group. So this is methyl formyl. Formyl for CHO group is not included in the parent chain and it is attached to one methyl group. So I'll write it as second position we have methyl and formyl and this is propane 1,3 dicarbaldehyde. Okay, and you can include here E. Here also you should include E. Here also you should include E. Okay, here also you should include E. E is only excluded. One more thing. E is excluded only when you have A, I, O, U or Y after that. Any vowel or Y after that. If you have E and Y, then E will be excluded. If you have E or A, E will be excluded. If you have E or I, E will be excluded. Okay? Done? Done. 3-methyl formyl, 2-methyl propane, 1,3 dicarbaldehyde. Very good. 1,3 carbaldehyde. Okay. Now, next question is this one. So, what is the answer to that? Let us see. What is the answer to this question? Now, CHO group is directly attached to one ring. That means here also the name for aldehyde group will be carbaldehyde. So how would you write it? Answer in the chat box. What is the main parent chain? Main parent chain is this cyclic group, that is cyclohexane. Right? Cyclohexane. Okay? Cyclohexane is the main parent chain here. No, this is not the main parent chain here. Yeah. Cyclohexane carbaldehyde. Perfect. Yeah. Cyclohexane. Right? And here in the first position we have CHO group directly attached to the ring. So it will be carbaldehyde. Now tell me, if you have this thing, how will you write it? If you have this thing, how will you write it? What is the name for this? Cyclohexane carbaldehyde. Perfect. No. This is not benzene. This is cyclohexane. Okay, I am not talking about benzene. Okay, so what is the answer to this? This is 1, 2, 3, 4. So this is cyclohexane 1,4 dicarbaldehyde. Okay, 1,4 dicarbaldehyde. Perfect. Okay, perfect. Now coming to next. That is what should be the answer to this? CH2CHO and this is CHO, and this is CHO. What should be the answer to this? Now understand this point. You have one CH2CHO group and two are directly attached. So if one aldehyde group is directly attached to the ring, that is called carbaldehyde. But if it is not directly attached to the ring, it is not carbaldehyde. So what will be the answer to this? Right now it's getting easier. Perfect. Perfect. So now tell me, what should we write it? How should we write it down? Simple. Same manner. Same manner. This is directly attached. So these two are carbaldehyde. This is not directly attached. So this will be methyl formyl. Formyl because the CHO group is not included in the parent chain. The parent chain is 1, 2, 3, 4, 5, 6. So this will be 2-methyl formyl cyclohexane. Then this will be 1,4-dicarbaldehyde. Okay, 1,4-dicarbaldehyde. Perfect. Perfect. What you want me to repeat? Okay, beta. So see, this is if CHO group is directly attached to the ring, the name given to that group is carbaldehyde. Okay, so this is cyclohexane 1 and 4 dicarbaldehyde, and here CHO group is 2 CHO group are directly attached to the ring, that is dicarbaldehyde, first and fourth position dicarbaldehyde. But at second position, the CHO group is not directly attached to the ring. It is CHO group is directly attached to the ring. That means this is methyl and this is formyl. Why I have written formyl here? Because this CHO group is not included in the parent chain. That is why it is excluded from the parent chain. So the answer is 2-methyl formyl cyclohexane 1,4-dicarbaldehyde. Okay? Okay, guys? Is this done? Is this done? Is this clear to everyone here? Is this clear to everyone here? Okay, guys, is this clear to everyone here? Tell me. Should I proceed next? Okay. So now what will be the answer to this? What will be the answer to this? What will be the answer to this? What is the answer? What is the answer to this question? What is the answer to this question? This is COOH group. Understand this. Understand this. I am writing it here. I am writing it here. Again, a cloud means this is important. Right? Carbon containing functional group directly attached to ring. Name changes. So the name for carboxylic acid is carboxylic acid only. We will not write it as oic acid here. It will be carboxylic acid because it will again eat the carbon. If carbon containing compound is directly attached to ring, then it will eat carbs. Okay, it will be carboxylic acid. So here I will write it as cyclopentane carboxylic acid, not cyclopentanoic acid. This is not cyclopentanoic acid. This is cyclopentane carboxylic acid. The reason is COH group is directly attached to the ring. Okay, if that is directly attached to the ring, that is carboxylic acid. Perfect. Perfect. Okay. So now next is what is the answer for this? 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 Now this COH group is not directly attached to the ring. That means here it is not carboxylic acid. Here it will not be carboxylic acid. What will be the answer to this question? What will be the answer to this question? Tell me, guys, what will be the answer to this question? What will be the answer to this question? Okay, so this is not carboxylic acid. Here we will write it as, here 1, this is the mean function group, right? 1, 2, And on second position, we have this substituent. On second position, we have this substituent, that is 2-cyclopentyl ethanoic acid. Ethanoic acid. Why so? What is the reason? Because here carboxylic acid is the main priority and that is not directly attached to the ring. That is why we have not written carboxylic acid. Rather, we have taken this as a substituent and this is the main chain here. Okay? This is cyclopentyl ethanoic acid. Perfect. This is cyclopentyl ethanoic acid. Perfect. Perfect. Now moving to next question. Moving to next question. We have COH. Here is COH. Here is COH. Now this is very easy. This might be very easy for you. What is the reason? Because we have done similar question for aldehyde. In case of aldehyde, I have written tricarbaldehyde. In this case, I will write tricarboxylic acid. That is the only difference here. That is the only difference here. That is the only difference here. So tell me, yes, what should be the, what Krishna? Okay. What should be the answer here? This will be 1, 2, 3 and the answer will be propane 1, 2, 3 tricarboxylic acid. Tricarboxylic acid, that will be the answer. Propane 1, 2, 3 tricarboxylic acid will be the answer to this, right? Okay, perfect. Perfect. Now coming to next question. Now tell me, what is the answer to this? What is the answer? This is a cyclohexane ring and COCl, that means acid halide is directly. So now, if carbon otherwise COCl means COCl, what is the IUPAC name for COCl? That is oil chloride. But if this is directly attached to the ring, the name changes. If carbon containing compound is directly attached to the ring, the name changes. How will it change? If carbon containing compound is directly attached, otherwise it would have been oil chloride. It should be oil chloride. In simple IUPAC naming, we write it as oil chloride. But if carbon containing compound is directly attached to the ring, the name changes and the name here will be, it will eat the carb and the name will be carbonyl chloride. Carbonyl chloride. The name will be carbonyl chloride. Okay, the name will be carbonyl chloride. Acid halide, acyl halide are the, yes, they are same. They are the same. Yes. Okay, now tell me, here it is carbonyl chloride. So this is cyclohexane carbonyl chloride. Okay, understood? Okay, understood? This is cyclohexane carbonyl chloride. Okay, perfect. Now coming to next, moving to next. There's just 2-3 more questions left and after that we'll jump to bicyclo compounds and then few common names. Okay, what is the name for this? What is the name for this? Tell me in the chat box, what is the name for this? What is the name for this? What is the name for this? What is the name? If you're still here, very patient, then you will succeed in life. What is the reason? Because very few students, only few students, they have the capacity to study for more than 2 hours. There are just few students and those are the few students who became doctor, right? Who become doctor. But if you lose your patience after 2 hours, then I think there's need for more motivation, more patience, right? Especially if it's just 4 months left. Okay. Now this is, what is this? Is amide group. So it will also eat carb. It is directly attached to the carbon. It is directly, very good. This is not amide. This will not be amide. This will not be amide. This will not be amide. This will be carboxamide. Carboxamide. Okay, have you written? Carboxamide, not carbonylamide. This is carboxamide. Okay. If carbon containing group, that is amide, is directly attached to the ring, the name changes to carboxamide, and this is cyclobutane carboxamide. Okay. Cyclo, I have taught you aldehyde, then carboxylic acid, then after that we acid halide, and now amide. Okay. Now amide, that is carboxamide. Okay. 4 functional group that have carbon containing, that have carbon, and if their carbon is directly attached to ring, the name changes like this. Okay. Okay, perfect. Now let us see who answers this. Let us see who answers this question. I want to see who answers this question. Let us see who is able to answer this question. Let us see Suresh, Svethu Prasad, Sarath. If I'm pronouncing your name incorrectly, I'm so sorry about it. Okay. Divya, Sanvi, Ramya, Aishwarya, Sheikh, Krishna. Tell me, bacha. What is the name for this compound? What is the name? This is exactly like CHO. Exactly like CHO. Perfectly like CHO. We have studied that. So what will be the? Very good. Tetra. No tetra. No tetra. No tetra here. This is 1, 2, 3. So this is propane, 1, 2, 3, tricarboxa. This is not carboxamide, this is carbonyl. This is carbonyl bromide. Carbonyl bromide. So when acid halide changes its name, it is carbonyl halide. Okay, so this is carbonyl bromide. Okay. Okay, the last question for this particular cases, that is for these particular cases, the last question, because I want to wrap up the IUPAC naming today itself. I want to wrap up the common names today itself, so that we can start off with electron displacement effects like electromeric effect, mesomeric effect, resonance effect, inductive effect, hyperconjugation effect, rearrangement of carbocations, stability of intermediates, aromaticity. All these things, definitely 10 to 15 mark question will come from these things. Okay, so you need to know those things, but before that, this is also important, right? So now tell me, what is the name for this compound? This is 1, 2, 3. Let us see who have named this correctly. Aishwarya, propane 1, 2, 3 tricarbonyl bromide. Perfect. This is carboxamide. Very good. Very good. This is propane 1, 2, 3 tricarboxamide. Okay, this is amide group, but that is due to symmetry, we have not included this, so name will be carboxamide. Okay, the name will be carboxamide. Perfect. Any question till now? After this, we are going to start with benzene compounds. We are going to start with benzene compound. Any question till now? Any question? Any problem till now? Any problem? Any problem? Any problem? You can ask me if you have any question, any problem. If you have any problem, any question, just let me know. Any question, any problem, just let me know. Okay? I'll send you this particular chart. And guys, this is the schedule for next week. Okay, next week the schedule for Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. You can note it down. I'm side. Wait. Okay. You can take a screenshot of this. Okay, this is your schedule. This is your schedule for next week. My class will be on Tuesday. On Tuesday, my class will be on Tuesday. Tuesday, 11 a.m. we will do inductive effect and the question based on it. And after that, on Thursday, 8 p.m. we will do resonance, resonating structures, mesomeric effect. Okay, these two most important topics of general organic chemistry, GOC. Okay, let's wrap up IUPAC naming and common names today itself. Are you with me? Tell me, are you with me or not? There are just few students left. Just few, I'm telling you, just few students left here. But I know you guys will make it. Okay, you guys will definitely make it. You need break? 3-minute break? Okay, you can take break. I'll talk to you in between. Okay, you can take. Perfect. That is in coordination compounds. When we will do the IUPAC naming of coordination compounds. Okay. Perfect. Now, benzene compounds. Benzene compounds. So you all know benzene, right? Very cute structure of benzene. Very cute structure of benzene. That is this. This is the benzene, है ना? Right? This is benzene. We write it as this. Someone saying, ma'am, you have not put circle in middle. Right? This is benzene. When you put circle, what is that circle? This is resonance. This is resonance of double bond and single bond. That is resonance. Okay. So, shall we start? I think 3 minutes break is done. Right? Okay. Perfect. I'll do that. After GOC, we'll have one shots or maybe in 2-3 lectures we'll complete the chapters, and after I'll complete your syllabus. Don't worry. Okay, don't worry. We'll do that as well. Okay. So now first is as per the demand, supply will be there. Okay. If the demand is of purification and qualitative analysis, we'll do that. So now what is the name? What is the name for this? Now let us do the IUPAC naming for this. So for this, go alphabetically. So how do we choose this? 1, 2, 3, 4, 5, 6. Either you can choose it 1, 2, 3, 4, 5, 6. But I am choosing this way. Why I am choosing this way? Because in this way, in this numbering system, I can give lower number to more substituent. That is why I am choosing this numbering. So this will be 1 bromo, 1 bromo. Some student will write it as 1 bromo, 2 nitro. But this is not 1 bromo, 2 nitro. This is not 1 bromo, 2 nitro. This is 1 bromo, 4 chloro, and this is benzene. Okay, 1 bromo, 4 chloro. I have not written nitro now. 2 nitro, and this is benzene. You should write it in the same line. Because of issues about space, I am not writing it in the same line. Okay. Okay. So next is answer this. What is the name for this? What is the name for this compound? 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 What is the name of this compound? This compound, as you all know, this thing is toluene. So we can also write it as ortho. This can also be written as ortho methyl toluene. Okay, this can also be written as ortho methyl toluene, because in ortho, at ortho position, what is the ortho position? This is benzene, this is the main group. This is ortho position, this is meta position, and this is para position. This is meta position, this is ortho position. So this is O my pal. Pal means friend, right? O my pal, right? O my pal, ortho meta para, right? Okay, so this is ortho methyl toluene, or you can also write it as 1, 2 dimethyl benzene. Both are correct. Okay, both are correct. 1,2-dimethylbenzene is also correct. Ortho-methyltoluene is also correct. Okay, both of these are correct. Okay, perfect. Now what is this? Answer this. If you go by IUPAC naming, you will say, ma'am, the correct answer to this is, the correct answer to this should be benzene carbaldehyde, right? If you go by the rules of IUPAC naming, it should be benzene carbaldehyde, but it is not benzene carbaldehyde. But it is not benzene carbaldehyde, although benzene carbaldehyde is correct. But you know, when a child is born, we give some nickname to that baby, right? Let it be Krishna, Krishi, Mishi, any nickname we give to that child. Now after that, you name a particular, you gave a proper name to that child, but in the house everybody is saying by that nickname. What is the reason behind that? Because now we don't care about logics. We are not taking the school name. We are taking the nickname. Why so? Of your friends also, you don't take their proper name. You call them by some nickname, right? What is the reason? What is the reason? Because that is how we know that person. Now, before IUPAC naming rules came, this was very famous as benzaldehyde. Benzaldehyde. Arre. This got famous by the name of benzaldehyde. This got famous by the name of benzaldehyde. Although benzene carbaldehyde is also correct, but this got the famous name benzaldehyde. That is why IUPAC have to accept this name as it is. Okay? Although by rules this is not correct, but IUPAC have accepted this name. Okay? But IUPAC has accepted this name. They have to accept this name because this is famous by this name. Right? Okay. Now next is what is this? And what is this? Okay, and what is this? What is the name for these three compounds? First is benzoic acid. Benzoic acid. It got famous by the name benzoic acid. It got famous by the name benzoic acid. Now what is the name for CuNH2? What is the name of CuNH2Cn? This is benzamide. This is benzamide. And what is the name for this? This won't be directly asked to you. This will be asked to you in some complex questions where you have to do the reactions. Then if you don't know these names, you won't be able to crack it. Okay. So what is this name? This name is benzanitrile. Benzanitrile. Okay. Benzonitrile. This is benzonitrile. Okay, perfect. Now moving to next. Now tell me what is the name for this? What is the name for this? What is the name for this? COCl. COCl. What is the name for this? What is the name for this? Now tell me what is the name for this? What is the name for this? What is the name for this? COCl? Benzoyl chloride. The name is benzoyl chloride. So that car beating thing is excluded now because they got famous by these names only. Okay, so IUPAC accepted these names even though the carbon containing compound is directly attached to the ring. Even then IUPAC have to accept these names because they got famous by this name. Okay, yeah, so this is benzoyl chloride. What is the name for this? This particular thing is phenol, right? So you can write it as orthohydroxyphenol. This can be orthohydroxyphenol, right? Okay, this can be orthohydroxyphenol or 2-hydroxy. Yes, this is also right. 2-hydroxyphenol. This is also correct. Okay, orthohydroxyphenol or 2-hydroxyphenol, both of these are correct, right? Okay, moving to next. Now this is your homework. Write this in the comment section. Okay, write this in the comment section. I am writing this. I'll give the homework in the end also. This is Br, this is COH, and this is CHO, and this is CHO. Okay, so I should solve it myself. I think few of the students might get confused in this. So let us see who answered this. I'll give you another homework. I'll give you some other homework. Okay, just tell me this is not your homework. I think some might find it little difficult. So tell me. So how will you write it? What is the numbering? What should be the numbering? This is the priority group. So this should be the numbering 1, 2, 3, 4, 5, 6. Right? This should be the numbering. Third position you have bromo. Fifth position you have formyl group. Very easy. Okay. Third position you have bromo. Fifth position you have formyl group because the CHO group is not included in the main chain. And last is benzoic acid. This is your previous year question. Right? These are your previous year questions that I am currently solving. These all are your PYQs. Okay? These are your PYQs. So now tell me, this is 2-bromo-5-formyl benzoic acid. Is this correct? Okay? Right? Done? I can see any student typing the correct answer. What happened to you all? What happened? What happened to you guys? You have lost energy or what? What happened? Okay, I'll give you some rest. Don't worry. I'll complete it and after some time I'll complete this. Okay. So now let's jump to bicyclo compounds. Arey. Let's jump to bicyclo compounds. Wait. I can't find. Wait. Yes. Okay. So let's jump to bicyclo compounds. So what are bicyclo compounds? Can anybody tell me what are bicyclo compounds? Most of the lecture is completed. So now bicyclo, spiro compounds, then few common compounds. That's it. Okay. And your IUPAC naming, common names, hybridization, everything, basic, everything is done today itself. Okay. So now tell me what is bicyclo compounds. Bicyclo compounds are the compounds that are having two rings, but in between those two rings, two carbons, more than at least two carbons should be common. What do I mean by that? For example, you have this ring, you have this ring, and you have this another ring. Now, what you see between these two rings, there are at least two carbon atoms. There can be more than two carbon atoms. It can be. This is also bicyclo compound. This is also a bicyclo compound. But this is having one carbon in between them. right? Total 3 carbon between them. This is having 2 carbon. So bicyclo compound should have at least 2 common carbons. It is having 2 common carbon, that means it is a bicyclo compound. So how do we name it? Ma'am, how do we name it? This is very simple. So firstly, you just need to write bicyclo here, write bicyclo and draw 2 brackets here, Write bicyclo here and draw 2 brackets here. Then calculate and count the number of carbon atoms in this compound. This is 1, 2, 3, 4, 5, 6. Right? This is 6 number of carbons. So this is, write it as hexane. Here write it hexane. Understood? Very simple. You just write down bicyclo, then 2 brackets, then total number of carbons in the end. Right? Okay. After that. Okay, perfect. You also have bicyclo compounds in bio. That is nice. Bio and chemistry are mostly interrelated to each other. So bicyclo, bracket and hexane, right? Now, see, in bicyclo compounds, you move from maximum to minimum. Maximum to minimum meaning, what do you mean by maximum to minimum? This means here you have 1, 2, 3. I'll actually round this by some other marker. 1, 2, 3. So this means exclude the common carbons. Do not count the common carbons here. Do not count this and this here. Okay. So in this ring you have 3 carbons. So write it as 3. And in this you have, do not even write it as 3. Just write it 3. And in this ring you have 1 carbon common. 1 carbon apart from common. Right? So this is 3, 1 and 3 dot 1. Maximum to minimum. First is 3, then minimum is 1. After that, do you have, apart from common carbons, do you have any carbon in between these common carbon? No carbon, so write it as 310. So this will be 310 hexane. Bicyclo 310 hexane. Understood? Should I give you one another example? Let us take one another example. I think that will be better for you to understand. Okay, now see, these are the common carbons. Right? So firstly what you do, write bicyclo here, and then bracket, then the number of carbons here. This is 1, 2. I would rather not draw this structure. This is actually not a very good structure to draw. Let us draw this structure instead. Yeah, I think this is nice. Okay, I think this is perfect. Now, see, let us count the number of carbons here. 1, 2, 3, 4, 5, 6, 7, 8. So this is total 8 carbons. You have total 8 carbons here. Right? Total number of carbons are 1, 2, 3, 4, 5, 6, 7, 8. Bicyclo, bracket, then total number of carbons. After that, maximum to minimum. So let us calculate how many carbon atoms excluding these two. So in this ring, you have 1 and 2 carbon atoms, right? In this ring, you have 1, 2, 3. 1, 2, 3 carbon atoms, right? Excluding the common carbons. And in the bridge carbon, you have 1 carbon. This is having 1 carbon. So this will be 3, 2, 1. Understood? Bicyclo 3 to 1 octane. This will be bicyclo 3 to 1 octane. Okay? Do you want another example? Do you guys want one more example for bicyclo compound? One more example, or are we done with this? 3, 2, 1. Okay? Done? Should we do spiro compounds now? Perfect. Let us do spiro compounds now. Spiro compounds. Let us see that. Spiro compounds. Spiro compounds. Spiro compounds have only one carbon atom common. There is only one single carbon atom common. So let us draw one example. There is just one single carbon atom common. One carbon atom is common between the two rings of spiro compounds. Okay. So very similar. Just write, while naming these kind of compounds, just write spiro. Write spiro. And then bracket and bracket. And now write the total number of carbon atom in this. Write the total number of carbon atom in this. Total number of carbon atom, how many? 1, 2, 3, 4, 5, 6, 7. So this is heptane. This is heptane, right? But in spiro compounds, in bicyclo compounds, we move from maximum to minimum. In spiro compounds, we move from minimum to maximum. From minimum to maximum. So write it as minimum to maximum. So in this particular ring, in this ring, you have 1, 2, 3, 4 carbon atoms. In this ring, you have 2 carbon atoms. So this will be 2.4 and no more dot after that. Why? Because we have just one carbon atom common for spiro compound. So this will be 2, 4 and this is heptane. Understood? One more example. So let us do one more example of spiro. I think I think this is getting excluded from this camera. Is it? You're not able to see the upper part, right? So I'll adjust the camera after that. Okay? Yeah. So just one more example. One more example of both bicyclo and spiro. Right? So you have okay. So this is, firstly tell me this is A and this is B. Which is bicyclo and which is spiro? Which is bicyclo and which is spiro? Which is bicyclo and which is spiro? Which is bicyclo? Which is spiro? Which is bicyclo? Which is spiro? A or B? A is bicyclo, right? A is bicyclo compound. This is bicyclo compound and this is a spiro compound. This is spiro and this is bicyclo. This is bicyclo because it is having at least 2 carbon common atoms and this is having just 1 carbon atom common. So now let us do the numbering, let us do the naming for this. This is bicyclo, so write it bicyclo, bracket, bracket, and now write it total number of carbon atoms. 1, 2, 3, 4, 5, 6, 7. Okay, so this will be heptane. This will be heptane. Also same here, write spiro and bracket and total number of carbon atoms. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is decane. This is decane, right? Okay. Now let us move to naming the brackets. How do we number the brackets? Right? So this is having 1. This is having 1, 2, 3. This is having, apart from common carbon atom, it is having just 3 carbon atoms. Apart from common carbon atom, it is having 2 atoms. So this is maximum to minimum, that will be 3, 2 and 0. Why 0? Because these common atoms do not have any single carbon atom in between them. So this is 0. In case of spiro, this is 1, 2, 3, 4, 5 and this is 1, 2, 3, 4. So this is minimum to maximum. This will be 4.5. Understood? Understood? Is this clear to you? This is bicyclospiro. Why I have named this as bicyclo-3,2,0-heptane, and this is spiro-4,5-decane. The only difference is here it is maximum to minimum, here it is minimum to maximum. Okay? Got it? Got it? Should we move ahead to the common names? IUPAC naming is done. All you needed for IUPAC naming, we have done that. Okay? We have done that. Everything that you need for IUPAC naming, we have done that. Okay? Done. Okay, perfect. So now let us move to common names. So few common names. I don't know if you are. Let us see who will be able to give the answer. Okay? So this is CH2, OH, OH. Answer these two. CH2, CH, CH2, OH, OH, OH. Now what is the name for these two? Very, very important compounds. Usually asked in the NEET exams. These two are very easy and usually asked in the NEET examinations. So what are the common names? This is the first and this is the second common name. Tell me. Yes. Okay, so first is CH2. This is ethylene glycol. Very good. Second is glycerol. Perfect. First is ethylene glycol. So you know glycerol, glycol, and this is glycerol. So you know these common names do not have any rules and regulations. These are just you have to cram it, right? But they are not all the common names that you have to cram. There are just few names that are very, very important and usually asked in your exams. Okay? So now first is ethylene glycol, second is glycerol. Now coming to next, answer this. Answer this. Okay, what is the answer for this? What is the answer for this? Again, important compound that is asked in your examinations. Yeah, this is in biomolecules. Yes, definitely it is in biomolecules. Yes, correctly. So now, correct. So now, what is the name for this? So, this is orthocresol. You can also write it as 2-methylphenol. You can also write it as that. But the common name that is very famous is orthocresol. This is metacresol. And this is paracresol. Okay, it is very famous by these names. Okay. No, this is not xylene. This is cresol. I'll come to xylene. Okay, we'll also do xylene. Okay, but this is cresol, orthocresol, metacresol, paracresol. Understood? Now moving to next. We have another common names. Yes. What is the name for this? This is something that can be directly asked. This can be directly asked in your exam. Directly. Because these are some of the names that are little tricky to learn. Okay? These are tricky to learn. This is directly given in your NCERT book. That is why these are important. The common names that are given in your NCERT book, I have picked all the common names from the NCERT book because the common names that are provided in your NCERT groups are that you must know. They can be asked directly, they can be asked in a question form, they can be asked for a reaction, but they may be asked because these are some of the names that are given directly in your NCERT book. Very good. What is the name? Very good. For when these OH groups are at the ortho position to each other, that is catechol. Okay, that is Catechol. The name is little weird. The names are very difficult to learn, but you have to learn these. Especially these three names. You can see your chart of alcohol, phenols and ethers, and you will directly get these names that are specially mentioned. Okay, that are specially mentioned. Very good. Catechol. Perfect. This is when in para position. When in meta position, that is resisonol or hydroquinone. That is resisonol or hydroquinone. When in meta position. Hydroquinone in meta position. In para position it is resisonol. Okay. This is also, what is another name for this? This is very famous compound. What is the another name? But I am really sorry about the echoing of the class. I know that, but that will be sorted today itself. Okay, that will be sorted today itself. I assure you that. Okay, I assure you that. The resorcinol, very good, resorcinol. And what is another name for this? What is the other name that is asked in so many exams? That is quinol. That is quinol. Okay? That is asked in so many exams. That is quinol. Catechol, hydroquinone or quinol and resisonol. Okay? Yeah. Okay. So now moving to next question. Okay. Now tell me. I think you must know this. What is the common name? What I am asking about common names, no IUPAC name, okay? OCH2, CH3 and very important. This is like most of the reaction you will see this. OCH3, benzene, OCH3 on benzene. That is, what is that called? OCH3 on benzene. OCH3 on benzene. Second check please, second and third check please, ma'am. Okay. I'm getting confused in this. I think I have interchanged. Yeah, even I feel I think I have interchanged this. Yeah, this must be resisonol and this must be hydroquinone. Yeah, I think I have interchanged this. Yes. I think I have interchanged this. Yeah, I'm getting confused in this. Yeah, I think I have interchanged, but I will update you on that. Okay. I think so. When I was getting confused in this, I got confused. I interchanged that. Okay. So now, what is this? This is anisole. This is anisole. This is anisole. What is this? This is also mentioned in your NCERT book. What is this? If you have OCH2CH3, this is cumene. Everyone knows this. This is cumene. What is this? Phenitol. This is phenitol. This is phenitol. Again important. Okay? Phenitol. Anisole, phenitol, and this is cumene. Cumene process. Right? Okay. Next we have, I think being a bio student you must know about this. Being a bio student you must know about this. OCOCH3. Being a bio student you must know about this. What is the answer to this? What is the answer to this? What is the answer to this? There's just few names left now. Yes, isopropyl. Very good. Isopropyl benzene or cumene. Very good. Third one is cumene. Yes, right. So what is the name for this? This is aspirin. That is banned now, right? This is aspirin. Very good. Aspirin. That is banned now. You already know a lot about these things because you're going to be a doctor. So I guess you know more about aspirin than me, right? Yes. Okay. So now, you know what? This question has been asked. This question has been asked in PYQs. In previous year question, you will see this. CH3 twice C double bond CHO. I think this is enough. So this question has been asked directly in PYQs. Directly in PYQs by some reaction, right? So the option was acrolein. Option was acrolein. I have named the answer. So the answer was acrolein, and you know what happened? Sometimes in some reactions, you know the structure of that reaction, you know what is the product form, what is the structure of that product. You don't know the common name. You can identify the IUPAC name, but you don't know the common name. So this was directly asked in, I think, 2020. It was back in 90s that was asked. Yeah. Okay. So this is acrolein. Okay. This is acrolein. Again, a very important compound. Next we have. Okay, just few 2-3 left. Just 2-3 left. What is this? What is the answer? What is the answer? What is the answer? If CHO are in ortho position and phenol and CHO group is at ortho position to phenol, or you have benzaldehyde and OH group is ortho position to this. What is the name? What is the name of these two compounds? This can be confusing to many. What is the name? Here, if CHO group are adjacent to each other, that is phthalaldehyde. Okay, and this is quite famous, right? This is salicylaldehyde. Okay. Okay, this is salicylaldehyde. Okay. Depending on the reaction. So, for example, in cumene process, byproduct is very important. Right? In cumene process, byproduct is important. But in few reaction, that is not important. Also, we don't consider byproduct. Sometimes we don't even write the byproduct of that reaction. Right? So, it totally depends on the reaction and what kind of mechanism it has gone through. Okay? So, now, what is the name for these two compounds? What is the name for these two compounds? COH and this is COH. This is similar to that, the previous one. This is similar to the previous one. COH and this is OH. The name is similar. The structure is similar. The name is similar. The structure is similar. Cumene acetone, yes. Yeah, acetone is a byproduct and that is very important. Okay. Cumene process, there are a lot of questions that has been asked in PYQs from cumene process, right? Okay, so yes, so this is phthalic acid and this is salicylic acid. Okay, these are some of the important common names, right? Few important common names, right? Understood? Done? Understood or not? Tell me, understood or not? Yes? Okay? Chal. Last question of today. Last question of today. Name of this compound. I'll just draw. You'll also get to learn this after we start aldehyde ketones and carboxylic acid. But here we are talking about common names. So these are also a few important common names. So this is CH2COH, COH, and next is CH2 twice COH, and this is COOH, and this is COOH, and this is CH2 thrice COOH, and this is CH2 4 COH, and this is COOH. Okay, this can be asked in reaction form. Okay, so now tell me the name for these. Tell me the name. What is the name of first acid? What is the name of first acid? That is oxalic acid. Very good. What is the name of second acid? Very good. Perfect. What is the name of second acid? Second acid, what is the name? If there is CH2 in between, in these COH2, COH functional groups, you have CH2 in between. If one CH2 is there, then it is oxalic acid. This is oxalic acid. This is malic acid, right? So this is malonic acid, right? Okay. You can learn it by this. Oxamallow. Oxamallow is the name of one girl. Oxamallow succeeded. Oxamallow succeeded. This is succinic acid. Succinic acid. Oxamallow succeeded what? What she succeeded? She succeeded glutoapple. She succeeded glutoadipic. Like glutonic acid. You can make a trick of your own. How I have learned this? Oxamallow, no? Also a meme is going on, right? Melona. I think that is the name. Wait. Yeah. One of the meme is going on, like melody, something like that. So, you can also learn it from that. Oxamallow succeeded. What she succeeded? Glutamic. This is adipic. Let me make a trick out of it. Oxamallow is the name of one person. Oxamallow succeeded. How can I make a trick of this? Glutonic and adipic. Yes. Okay. So these are very important compounds. You must know the names and structures of these. These are very easy to learn, right? Very easy to learn, very simple. But you know what happens in some reactions and directly this can be asked. So usually these are not in a very concise manner given in NCERT. So these are in chapters, you will see in tables. So I have compiled all those common names for you, and these are the most important common names from your NCERT itself and your previous year questions. Okay, right? Oh, very nice. Sarat said, Oxamallow succeeded, got apple. Oxamallow, publicity is not publicity. How can we define publicity here? Succeeded and got apple. She got an apple, right? She got an apple. Okay. Oxamallow succeeded and got apple. Apple phone, Apple iPhone. Okay, not that carnival apple. We don't care about apple that we eat. All we care about is iPhone, right? That is more important to us, is it? Or no? Okay. So I guess yes. One more compound that is left. That is, I think you all were talking about this. Just a minute. Just a minute. I guess so. You all know the answer to this. What is the answer to this? This is that xylene, right? So this is that xylene. This is orthoxylene. This is metaxylene, and this is paraxylene. Okay, got it? Okay, It's Sharath ma'am. Okay, okay. So sorry. I'm so sorry about the pronunciation. Okay, sometimes this happens. Okay, perfect. So, guys, this was the hybridization. So, today we have discussed the hybridization of carbon, nitrogen, oxygen. We have discussed that. If it is having 2 atoms, 3 atoms, we have discussed everything. After that, we have discussed few questions on that. And then IUPAC naming from a very basic, like from talking about what is propanoic acid to polyfunctional groups, right? We have gone from basic to advanced level. Then we have discussed benzene compounds, then bicyclo and spiro compounds, and now we are discussing common names. And few common names are left, but we will do those common names when we are doing the chapters. But most of the important common names I have already covered in this session. Okay? Okay? Okay, cool. Okay, perfect. So now I am going to give you some homework. Let us see. So this is your homework. I am going to give you 2 questions. 2 questions. Okay. Yes, I am going to, this is the first question. You need to name this. This is the first question. This is the first question. And now, I think that is enough. That is your homework. Okay? That is your homework. Yes. That is your homework. Or do you want one more question? Let me see. Okay. Okay. Single, double, and you need to tell me how many sp2 carbon atoms. Okay, these are the 2 questions. First is IUPAC naming of first one, then this how many sp2 carbon atoms. Okay, this is your homework. This is your homework, and you will have the time after. I'll see the comment section tomorrow before 6 p.m. Before 6 p.m. I am going to see the comment section. I'll see if you have answered it or not. And those students who have answered it, I know they are very sincere. And those students who don't do homework, I think they're not very sincere. So I get hurt by that. Okay. If you're doing your homework, that makes me happy. And if you're not doing your homework, that makes me sad. That okay, we are, doing so much hard work for them, and they're not even doing one question as a homework. Okay. So you need to solve these 2 questions. Write it in the comment section. I'll see how many of you have answered it correctly. And if you're not able to answer it correctly, that's completely fine. You just need to answer it. Okay. Even if you're wrong, I'll correct you. Okay. So that is the rule of this class. So now we are going to discuss, we are going to start general organic chemistry from Tuesday onwards, and Tuesday we are going to discuss about inductive effect. Okay, that is very important, most important concept, inductive effect, resonance and hyperconjugation. We need to solve all the questions. We will solve the so many questions and previous year questions that are asked in the in your NEET examination on Tuesday itself. Okay. And the class is 11 a.m. I'll see you in the morning, 11 a.m. Okay. Any doubts for today? Any doubts? Any doubts? Any doubts? No? Okay. Thank you. I hope so. And do share this with your friends, because it's the first time that I'm teaching on this channel. And I'm feeling very happy actually. Okay, I'm feeling very happy, and you guys, I have connected to you all for the very first time, and it's so good to know that you have been so responsive and you are giving proper responses, you are giving answers. I like such students who give answers, who are very active. So it also makes my energy high. Okay, if you're not giving the answer, I feel okay, now what is happening? But if you're giving the answers, I feel like okay, perfect. So we are hard work. We are giving our full potential to them, and they are also reverting it back to us. So that makes me very happy. So I hope to see you more of you now. The strength was very low today. So bring your friends here so that we can start with general organic chemistry with full energy. We will start with inductive effect. That is going to be a very important session. After that, we are going to do resonance. Okay. So Tuesday, inductive effect 11 a.m. Thursday 8 p.m. resonance, resonating structures and mesomeric effect. Done? Okay. Isomerism topics will be conducted in details, in full-fledged detail. I'll take a different, after GOC, after completing the electron displacement effects, we'll do isomerism, optical, structural, we'll do everything in detail, okay? You can leave your organic chemistry on me, okay? But just one thing I need from you, that is consistency. If you're not consistent in organic chemistry, even one single lecture can cost you so many marks. Okay? Trust me, my students whom I have taught, they know the importance of general organic chemistry, especially these electron displacement effect. When you move to the chapters, hydrocarbons, alcohol phenols, aldehyde, carboxylic acid, then when you solve the questions, then you know the importance of general organic chemistry. Now I am teaching you general organic chemistry in full-fledged details, so take advantage from it. Do take advantage of it, okay? Because if your foundation is weak, the whole building will collapse, okay? Just mark this thing. Okay, then bye-bye, take care, see you soon, see you on Tuesday, 11 a.m. and do your homework in the comment section. I'll see how many students have done the homework. Bye-bye.